Okay, folks, we're going to make a start. It is 9 o'clock now. Welcome to all of you. My name is Paul, and with my sister Ruth, we run an organization called SIMI, which is short for the Shai Izibalo Maths Institute. And you've obviously come to hear about us from our social media posts. We would appreciate it if you would like and share and follow and subscribe and do all those good things. Next year, SIMI will be supporting grade 9 as well. This year we've been supporting grade 8 and 12. So we will be building through the years, the year that you are in. So in other words, next year we'll be doing full support for grade 9, the following year for your grade 10, etc. So I think that's good news. So we're going to dive straight in. At the moment, I've muted all of you, all right? So I'm trusting that you can hear me. What I would like you to do, there's a reaction button up at the top of your screen, so you can send a reaction. I would like you just to put a thumbs up if you can both see and hear. Thanks, Erin. Okay, so lots of you putting thumbs up. Thank you very much. You also do have access to the chat. You'll see just the top left of your screen is a chat option. All right, and you can raise your hand as well. All right, so I'm going to try, okay, and we will see. I'm going to try and allow you to unmute yourselves. From my past experience, it becomes problematic with people being unmuted and it just being too noisy. Okay, so we will try, but we're going to dive straight in, and I will then, when I ask my first question, I will allow you to unmute yourselves. Okay, so the first thing is just a whole lot of stuff around number. Okay, and really number is the foundation of everything else. Okay, so we need to know kind of a few concepts. One of the things we need to know is what is a prime number. And remember, a prime number, the best definition is one that has a prime number has exactly two factors. Okay, not more and not less. All right, so for example, a number like 8 is not a prime number because it's got 1, 2, 4, and itself 8. So it's got 4 factors. A number like 1 is not a prime number because it's got one factor only. Okay, so it's only got 1. All right, so 1 is not a prime number. But a number like 2 is a prime number because it's got exactly 2 factors, 1 and 2. Okay, right. So I am going to try allowing you to unmute yourselves, and please keep yourself muted unless you are answering a question. Okay, and we will have a break every 40 minutes. Okay, well, every 40 minutes for 10 minutes we'll have a break. Right, just so you know how that's going to work. Okay, it's great to see some people online, and it's great to see someone saying that they're excited to be here. I am too. Okay, cool. Let's dive in. So all the prime numbers between 20 and 40, and I'm going to allow you to unmute yourselves. All right. So the problem is if you all unmute yourself and all start talking at once, we're not going to hear anything. You will see the little picture of the microphone. If it's got a line through it, you're muted. You can unmute yourself by clicking on it, but as soon as you've answered, then mute yourself again. I'm going to dive into this first question myself. All right. So the first prime number between 20 and 40 is actually 23. Right? There are no more even prime numbers after 2. 2 is the only even prime number. So I don't need to look at 24, 26, 28, any of those. All right. But the next one, in fact, is going to be 29. And please let me know if I've made a mistake and left one out. The next one's going to be 31. 33 is not, 34 is not, 35 is not, 37 is also a prime number. Right, and I'm really confident that those are the lot. Okay, all right. I don't know if someone would like just to quickly unmute themselves and give us the first 6 multiples of 3. Okay, 3 times 1, 3. Yep, I've heard somebody. Ogushle seems to be unmuted. No, it's not Ogushle. Sorry, I don't know who's unmuted themselves, but whoever has, maybe you can tell us what are the first 6 multiples of 3.
6.
Yes.
3.
Yeah, I've got 3.
9.
9.
12.
12.
15.
Yes.
18.
18, yeah, that's it. Okay, great. Thank you. Just mute yourself again. All right. Give the even multiples of 3 between 30 and 50. Okay. Now the word between, all right, it says that we don't include, okay, if we said from 30 to 50, all right, between, we're not going to include 30, okay? So we're now going to look at the multiples of 3, and they're quite easy to count. 33, 30, but I'm not going to write 33 down because it's odd. 36, 39, I'm not going to write down. 42, 45, I'm not going to write down. 48, and those are there. All right. Okay, all the factors of 60. Okay, so that's quite straightforward. We're going to just write down, and it's quite useful to write them down as factor pairs. In other words, 1 goes with 60, right? 2 and? Sorry, someone said 21 is a, sorry, just going back, someone said 21 is a prime number. 21 is not a prime number. 21 is 3 times 7. Thank you for putting that in the chat. All right, so 21 is not a prime number. Okay, all right. 2 and 30. 3 and 20. 4 and 15. 5 and 12. 6 and 10. Notice I'm all right. And 6 and 10, 7 is not a factor. 8's not a factor. 9's not a factor. 10 is a factor, but I've already got it. Okay. Notice that all numbers have an even number of factors apart from perfect squares. All right. So if we count the factors here, the reason that there's an even number is because they occur as pairs, all right, in twos. So we've got those two, those two, those two, those two, etc. Okay, if we look at a perfect square, a number like 16, it will have an odd number of factors. And let's just understand why, all right? Because 1 and 16, obviously, 16 is an even number, so 2 must be a factor, 8. 3 doesn't go into 16. 4 goes into 16, but it goes with itself, all right? And that's why we get an odd number of factors for a number like 16. So any perfect square will have an odd number of factors. All other numbers will have an even number of factors. Okay, right. Okay, looking for an answer for someone to give me all the even factors of 28. Numbers that go into 28 that are even. Okay, you guys have been good about not unmuting yourself and making a noise, but you're also not answering any of my questions, which is not making it any easier. Anyone want to give me even factors of 28? Even if you just give me one, that would be helpful.
It's going to be 1.
Okay, so we are getting a little bit of background noise now. So only unmute yourself if you're going to answer the question.
2.
Okay, so Jason's saying 1 and 28. Okay, 1 is not an even number. All right, I'm happy to write down 28. Okay.
2.
2, yes. 2 goes with what? Let's put 2. What does 2 go with? It goes with 2 times what gives us 28? 14, correct. Okay. 3 is not even. Is 4 a factor of 28? Does 4 go into 28? Yes. How many times?
Yes.
Goes in 7 times. Okay, so 7 is not an even number. All right. I think that's all of them, okay? Because 5 doesn't go in, 6 doesn't go in, 7 doesn't go in. Sorry, 7 does go in, but it's not even. And yeah, so that's the lot. Those are the only even factors of 28. All right. A really big thing is to read the instruction carefully. So don't just rush in and miss out the word even and only write down the factors of 28. Okay. So we are starting to pick up some background noise of people. Please try and mute yourselves if, otherwise I can just mute all of you, which I'd rather avoid doing because then it becomes just me talking. Okay. All the common factors of 40 and 60. Okay. So let's just write down the factors of, okay. So, it's hard for me to see who it is that's unmuted. Okay, so Zingisa, we are hearing a lot of background noise from you. Okay, so I'm just going to try and mute you, but I guess I can't do this. Okay, I'm just disabling that one. Okay, for now. Right, there are obviously others as well trying to see. Okay. Okay, so I've muted everyone. You're still able to unmute yourselves to answer a question. Okay. Right. Common factors of 40 and 60. Okay. So one thing we could do is we could write down all the factors of 40, and I'm going to write them down in pairs. So 1 and 40, 2 and 20. 3 doesn't go into 40. Remember the way we can test for divisibility by 3. If we add the digits up and we get a multiple of 3, then yes, but here we don't. Okay, 4 goes into 40, obviously 10 times. 5 goes into 40 8 times. All right, 6 doesn't, 7 doesn't, 8 we've already got. So those are the factors of 40. Now underneath my blue pen, I'm going to write down the factors of 60. All right, and so we've got 1 going with 60, 2 going with 30, 3 going with 20, 4 going with 15, all right, 5 going with 12, all right, and 6 going with 10. 7 doesn't go in, 8 doesn't go in, 9 doesn't go in, and 10 we've already got. So we've got there. Okay. So now what we're looking for is those factors that are common to both. All right. 1 is the common factor of actually every number. All right. Both of these have got 2 in them. Both have got 4. No, they haven't. Yes, they have. Both have got 4 in them. Both have got 10 in them. And both have got 5 in them. All right. So I think, oh, and in fact, both have got 20 in them as well. All right. Okay. So it looks like that's the lot. Okay. Just going back to the chat just to see if anyone's typing questions in there. Remember, you can raise your hand if you're not sure of something. This stuff I want to try and get through quite quickly because, to be honest, the only way you get better at this stuff is just by practicing number. There's not really much I can teach you here. All right. So in terms of writing down the common factors, all right, let's write them down here with an orange pen. They're going to be 1, 2, 4, 5, 10, and 20. Those are the common factors. Okay, so they are factors that are in both numbers. Right. The highest common factor of 18 and 48. Right. Well, again, this just depends how well you know your numbers. All right. But in fact, if we think about the factors of 18, 6 is definitely a factor. All right. Okay. And 6 is actually the biggest factor apart from 18 itself. 18 doesn't go into 48. 6 does go into 48 and into 18. 6 is what we call the highest common factor. Right. The lowest common multiple of 12 and 30, we want to find the first number that they both go into. And again, it depends how good you are with number, right? But if we start writing down multiples of 12, 12, 24, 36, 48, 60, all right? If we start writing down multiples of 30, in fact, just 30 and 60. So in fact, 60 is the first number that they both go into. 60 is the LCM, the lowest common multiple. Okay. And we use those common multiples in terms of factorizing in terms of adding fractions and things. We'll get back to that in a little bit. Right. The quickest way to prime factorize numbers, okay? And we're in KZN where I live, we've just changed all our number plates. So for example, my wife's number plate is CS18TXZN. Right. The nice thing about these new number plates is that you can look at them and you can prime factorize them, okay? 18 prime factorizes to 2 times 9, but 9 is not a prime, so 2 times 3 times 3. 18 is 2 times 3 squared. The way we get better at numbers is we practice them. All right, so as you're driving down the road, all right, prime factorize car number plates. Okay, the way I'm going to do 300 is actually going to, I'll show you how I'm going to do 300. Let's do 3. And I'm going to put 3 in a circle. And the reason I'm putting 3 in a circle, it's a prime number. 3 times what gives us 300? 100, okay? 100 I'm not putting in a circle because it's not a prime number. Okay, now as you get better at this, you might know, well, 100 is actually 2 squared times 5 squared. You might know that, all right? But let's suppose you don't know that. We could break 100 into, and there's different ways we could do it. You might say, Paul, could we do 10 and 10? Yes, we could. Could we do 4 and 25? Yes, you might know that 4 times 25 is 100. I'm not putting either of these in a circle because they are not prime numbers. Okay, what we're going to do now is we're going to break 4, and remember, we can't use 1. 1's not a prime number. 2 and 2. I'm putting those in circles because those are prime numbers. 25, don't go 1 and 25. That's not going to achieve anything. 1's not a prime number anyway. 5 times 5. Okay, and so now the answer for this, the prime factorization of 300, and the way we're going to write it, we're going to write down the lowest prime number, and then we're going to put an exponent on it because we've got 2 2's. 2 times 2, so I'll write this one out in full. 300 is actually 2 times 2 times 3 times 5 times 5. All right, so in fact, 300 is actually 2 squared times 3 times 5 squared. Okay, I'm going to give you, I'm going to give you 3 minutes. And I want you guys to try and see if you can do any of these. And then I'm just going to ask you I'm going to ask you to unmute yourself and give your answer for the prime factorization of any of these. All right. I can prime factorize all of them in my head. And that's not because I'm cleverer than you. It's because I practice. Okay. I don't use a calculator unless I really have to use a calculator. Okay. So I'm going to give you a couple of minutes just to quickly try and prime factorize these. And then we're going to ask some people for answers. So you can pick one. You might say, oh, I feel like doing 450. That's fine. Let's just try and each do at least one, and we'll take the answers now. Okay, I see Ogusle's got your hand up. Ogusle, if you want to unmute yourself and ask a question, you're very welcome.
Sir,
Yes.
one thing that I ask, are we allowed to do the ladder method?
Yes, totally. You can do that. You can totally do the ladder method. So I'll quickly remind. I'll do one of them with the ladder method. Yes. The ladder method is a little bit slower than this method, actually. That's why I use this method. And I can use this method. I can do it in my head. The ladder method, I can't keep track of what's happening. Okay, so yeah. But you're very welcome to do the ladder method. Yeah.
Thank you.
Okay, as soon as anyone's got an answer for any one of them, just unmute yourself and what I'm after really is just your final answer.
Comfortable. No, this sounds comfortable.
So
Yes.
for 280, I've
Yes.
got 2 cubed multiplied by 5 multiplied by 7.
2 cubed multiplied by 5 multiplied by 7. All right. I'm fairly sure that's right. Okay. And the way I would be thinking about 280, I'd be thinking about 28 times 10. Okay. Now 28 times 10, 28 is not prime, but 28 is 4 times 7. So that's where 2 of your 2's are coming from. And the 10 is 2 times 5. Well done. 100% right. Okay. Excellent. All right. I am going to quickly do this one using the ladder method. Okay. Please just mute yourself again, guys, because you can already hear we're getting a hell of yeah. Mute yourselves, please. Okay. the way the ladder method works, we start with the smallest prime number we can think of. We say, does 2 go into 280? And the answer is yes, it goes in 140 times. Does 2 go into 140? Yes, it does. It goes in 70 times. Does 2 go into 70? Yes, it does. It goes in 35 times. Does 2 go into 35? No. Then we try the next smallest prime number, which is 3. 3 doesn't go into 35 either. Then we try the next smallest prime number, which is 5. It does. It goes in 7 times. And then we see what's the smallest prime number that goes into 7, and that's 7. The answer is there. And now we can see that what we've got is we've got 3 2s multiplying together, and there they are. We've got a 5, and there it is. All right, and we've got a 7, and there it is. Okay. Anyone want to give me? I'm not going to go through all of them, but if anyone can give me an answer for 450, that would be wonderful.
Sure.
I'm also looking for an answer for 720.
450.
Yes.
2 times 3 squared times 5 squared.
Well done. I think that's right. I'm saying well done. Okay. 3 squared is 9. 9 times 5 is 45. We've got the other 5 and the 2 to make the 10. Well done. Excellent. Okay. All right. Okay. So, I'm looking for an answer for 720 from someone, please. Anyone? 720. I'll give you a 72 times 10. So really, in my mind, I've got 72 and I've got 10. Anyone want to give me the final answer? Yes, and number 10 has got a hand up. If you can unmute yourself and ask a question if you want to. Number 10, you just click on the microphone picture. You can unmute yourself and you can ask me your question.
It's 2 to the power of 4, 3 to
Yes.
the power of 2 times 5.
Okay, well done. Okay, I'm pretty sure that's correct. I'll tell you why I know it's correct is because where I got to here, I got to 72. 72 is actually 9 times 8. 9 is 3 squared, 8 is 2 cubed, and 10 is 2 times 5. Okay, so we've got 4 2s altogether. Well done. 2 3s and a 5. Excellent. Well done. Okay, right. Now, the reason this is important, guys, is that, so I'm going to just quickly write those prime factorizations down again here. So 300 is 2 squared times 3 times 5 squared. I'm just writing them again so I can see them all. The next one was 280 is 2 cubed times 5 times 7. The next one is 450 is 2 times 3 squared times 5 squared. So 2 times 3 squared times 5 squared. And the last one, 720, is 2 to the 4 times 3 squared times 5. Okay, excellent. Right, now, to find the highest common factor of two numbers, all right, what we do, we can't, if we look at these two numbers, let's look at 300 and 280. So we're looking at, I'm just going to shade them both yellow, all right, 300 and 280. And 7 will not be a common factor of 300. Right. And the reason for that is there's no 7 in 300. Right. But 2s and 3s are common factors. So there's 2s and 3s in both. So the HCF, what we do is we write down how many 2s there are. So we write down 2 times 3. We only write the common bases. Okay. For highest common factor. Okay. Now, what we now look at is we say, okay, what's the biggest number of 2s that is common to both? Okay, and that is 2. So we can't put 3 2s in. We can't put 3 2s because If we put 3 2s, it won't go into 300. So in fact, we actually, when we're finding the highest common factor, we actually take the smallest power. Okay, so of the powers of 2, we've got a 2 and a 3, we take the smaller one. Of the powers of 3, we've got a 1. Okay, all right, I've messed this up. We don't have any common powers of 3, okay? Luckily, I picked that up. There's three doesn't. There's no 3 in the next one. What I can use though is I can use 5. All right. Of the powers of 5, I've got 2 5s here. I can't put 2 5s because 2 5s won't fit into that number. So I can only put 1 5. I take the smaller number. All right. So of the 2 5s and the 1 5, I take the 1, and that is our answer. All right. We can work that out. It's actually 4 times 5. It's actually 20. 20 is the biggest number that goes into 300 and into 280. All right, the LCM we write down, now we're looking for the LCM of these other 2 numbers. I'm going to shade those green. We're looking for the LCM of 450 and 720. Okay, so we need for a number to be able, for both these numbers to be able to go into these things, we need to have all the bases. Okay. Every base, even if it's not a common base. All right, so we need to have a base of 2, a base of 3, and a base of 5. Okay, and then it's kind of backwards to what we did last time. When we're finding the lowest common multiple, we actually take the biggest number of 2s that we've got. So we take 4 2s. We take the biggest number of 3s that we got. Here we've got 2, here we've got 2, so we just take 2. We take the biggest number of 5s that we got. Here we've got 1, but we take 2. Okay. And that will be our answer. Right. This is actually a reasonably big number. If I take 2 2s from here with those 2 5s, I get 100. And then I've got 9, and I've still got 2 2s here. So it's actually, this number here is actually 3,600. All right. And 3,600 is a multiple of both of those numbers. Okay. I'm going to just bring up a calculator. Okay. And I'm going to close that calculator down. And I'm going to bring up this calculator here. It's just a simpler calculator. All right. And I'm just going to quickly check that I've got that right because I did it quite quickly in my head. I'm going to check that 3,600 does divide exactly by 450. It does. It goes in 8 times. And I'm also now going to check, does it actually divide by 720 as well? It does. It goes in 5 times. Okay. All right. Okay, now the smallest number by which 280 can be multiplied to give a perfect square. Now remember, for a perfect square, what we want is we want 2 identical numbers multiplying together. So we want to share these, factors, okay? I see Ayama's got her hand up. Do you want to give us an answer for this, or have you got a question?
No, thank you, sir. I forgot the question I wanted to ask.
Oh, no problem. Okay, cool. Just before we move off here, I just want to write this as a little note for ourselves. When we're finding highest common factor, we only take the common bases.
May I ask,
Yes, yeah.
what page are we in?
Okay, we're on page 3.
Which workbook? Page term 1 or term 2?
No. We're on a revision workbook. I'm going to see if it's a separate workbook. I'm going to see if my sister can maybe just put a link in the chat for the workbook so that you can see which workbook it is and download it. Okay, but it doesn't, even if you haven't got the workbook, you can just follow on the screen. Okay, I'm just going to quickly send a voice note to my sister and see if she can do that for me while I'm doing this. Well, you know what, we're having a break in 10 minutes time. I'll find the link and I'll put, in fact, I don't know if I can put a document into the chat. Let's try that.
Okay, thank you.
Okay, I don't think I can put a document. No, I can't. I'll do it when we have a tea break. Okay, all right. So just what I was saying here is, for the highest common factor, we only use the common bases. For the lowest common multiple, we use all the bases. And for the highest common multiple, we use the highest, sorry, for the lowest common multiple, we use the highest power. So it's kind of the opposite in both cases. Okay, all right. So if I look at 280, if it was a perfect square, I would be able to group the factors into two identical groups, okay? And if it's a perfect cube, I would need three identical groups, okay? So let's look what we've got for 280. We've got 3 2s, okay? Now, I can put a 2 in this bracket and a 2 in this bracket, okay? Now, I've got to put a 2 somewhere, so let's put another 2 in here, right? And then I've got to put a 5 and a 7 in as well. I haven't got a 5 to put. Okay, so I've got a 5 and a 7. Right, now, what do I still need to put into this other bracket to make it identical? And I'm going to write these ones with a red pen. These are ones that I don't have. To make it identical, I'd need another 2, and I'd need a 5, and I'd need a 7. Okay, that number there is 10 times 7, 70. If we multiply 70, our 280 by 70, we'll get a perfect square. And I'll show you that, all right? If we work out 280 times 70, right? It's quite a big number. That number there is a perfect square. And you might say, well, can we check it? Of course we can. We just press the square root of our answer and it works out exactly. It works out to 140. And we can see why it's 140 because 2 times 2 times 5 times 7 is 140. Okay. All right. Okay. Right. The smallest number by which 450 can be multiplied to give a perfect cube. 450, we've got, I'm going to just make this a little bit smaller so I can fit it all on the same screen. 450, we want to break 450 into 3 identical brackets. 3 identical numbers, okay? And this is going to be a bit of a problem because I've only got 1, 2. All right, so I can write a 2. I've got a 3. So let's put a 3 in this bracket. Let's put a 3 in this bracket as well. So I've used all my 3s now. I can put a 5 in this bracket. And I've got 1 more 5 I could put in this bracket. Now, I need these brackets to be identical, all of them. So I would still need, and I'm writing with a different pen color. I'm going to write them with blue this time. I would need a 2 in this bracket to make it identical. And in this bracket, I would need a 2, a 3, and a 5. Now, if you look at all the numbers that I put in, all the blue ones, they actually multiply together to give me 60. 2 times 2 is 4, times 3 is 12, times 5 is 60. If I multiply 60 by 450, I will get a perfect cube. Have a look at this. 60 or 450 multiplied by 60. Okay, quite a big number. It's 27,000. Okay, now I can tell you we don't need a calculator to know that 27,000 is a perfect cube. 1,000 is a perfect cube because it's 10 times 10 times 10. And 27 is a perfect cube as well. All right, because it's 3 times 3 times 3. If you wanted to see on your calculator, there's this little button over here with a little cube root on. We go shift cube root of our answer, and we get 30. Okay, and if you look, each of these brackets is 30. All right. Okay. Right. We're now moving on to the next topic. We do need people to mute themselves. Okay, so guys, we are and Emma, you have your hand up. If you want to take your hand down, just press raise. Just raise your hand again, if that makes sense. Then your hand will go down. If you want to ask me something, you're welcome to unmute yourself and ask me. Okay. All right. Okay. Ogushi's got their hand. Yes. Okay. So, and Zingis has got 2 hands up. Okay. All right. Guys, you're welcome to unmute yourself and ask a question. Okay.
Sir,
Right. Yes. Yes.
for page 2,
Yes.
for page 2, the alphabet H, you didn't get the answer.
And H.
Yes, for page 2.
The lowest common multiple.
Oh, thanks.
Okay, it is definitely 60. Okay. Because I wrote down the common multiples, so I'm not sure. So basically, I just started writing down the multiples of 12. 12 times 1 is 12. 12 times 2 is 24. 36, 48, 60. I knew that 60 was the answer before I started because I stopped there. All right. The next one would be 72, but I didn't write that one down. Okay. All right. And then I started writing down the common factors of 30. 30 times 1, 30. 30 times 2, 60. And then I said, oh, hala, I've got a common factor. A common multiple, not a common factor, a common multiple. Okay. Right. Any other questions, guys? Sure. Any other questions before we go on to integers? Okay, so the big thing with it, yeah. Okay, that's just background noise, I think. Guys, the big thing with integers is that
Then now you were cut off. Please go back to the sum that we just did now. Got cut off.
Okay, yeah, guys, it's actually this one over here is H. I don't know if you talk about that one or the one before.
M.
Okay, yeah, M is the one. Yes. So we were trying to break 450 up, and there's 450. It's got three twos, 2 5s. We're trying to break it up into 3 identical brackets to give a perfect cube. Okay. So we managed in red pen, we managed to use up all the bases that we had. We put a 2, we only had 1 2, so we put that in the first bracket. We had 2 3s and 2 5s, so we put a 3 and a 5 and a 3 and a 5. And then to get the brackets equal, I put in with my blue pen what we needed to make them all the same. I needed to put a 2 in here, and I need a 2 and a 3 and a 5 in here. If you multiply all of these numbers together, you get 60, and and I just then showed that in fact, if we multiply 450 by 60, all right, we actually get 27,000. And then I showed on the calculator, but in fact, you can also do it in your head. The cube root of 27,000 is actually 30. So it works out perfectly to 30. And 30 is what each of these brackets comes to. All right. Because now we can see that 450 is actually 30 times 30 times 30. Okay. All right. Okay, guys, the integers, really important is in our mind is to have a picture of a number line. Okay, and it gets bigger going to the right, smaller going to the left. Okay. So the first thing we need to be comfortable is ordering numbers from biggest to smallest. I would love it if someone could unmute themselves and just tell me, write them down for me. Just read them out, biggest to smallest, okay? I will help you. I'll cross them off as you give them to me.
The big one is 6.
Okay, I'm seeing a big
3.
I'm seeing a bigger one than 6. I'm seeing 9.
Oh, 9 is the
9.
big one.
Okay, so 9. Let's start with 9.
7. 7.
I'm seeing one bigger than 7.
8.
8, eh?
8,
7.
7,
6. 5.
6.
0.
There's a bigger one than 0.
6, then 0. Then 3,
No.
then 0.
Yes, after 6 is 3, not 0. And then,
3.
okay, now guys,
Then
now
0.
we have done all the positive ones. 0 is the next biggest number. All right. Okay.
Negative
And then-
2,
Okay, now negative 2.
negative 11, negative 12.
Well done. Negative 2, negative 11, negative 12. Okay. What's very confusing here is that I've got these words the wrong way around. Okay. Okay. This word, biggest to smallest, guys, is actually descending. I'm really sorry. Okay. That would have confused everyone. Okay. And the next one, I want them from smallest to biggest, and that word is ascending. To descend means to go down. To ascend means to go up. All right. You might know there's a day on the church calendar called Ascension Day, and that remembers and celebrates Christ going up into heaven, ascending. Okay, so this should be ascending. Okay, my alarm's going on my phone to remind me that we need a break, but let's just quickly do this question here. Okay, before we have a break. So this time we're going from the very smallest number to the biggest number. So we want to look for the most negative number, if that makes sense. Okay, the number that would be the furthest to the left on our number line.
Can answer.
-7.
Yes. Yeah. Okay. We've got a couple of people.
-10.
Negative.
-10.
Then
-10.
-5.
-7 first. Huh?
-7.
-5.
-5.
-2.
-2.
Negative.
-1.
-1, then 0.
One,
-1.
0.
0,
3.
Yeah.
11, 12,
3, 4.
4.
9.
9. 11. 12.
11, 12.
12.
Yeah. Well done. Okay, great. 3, 4, 9, 11, 12. All right, now guys, we're gonna take a 10-minute break. Guys, we're gonna now get into adding and subtracting integers. Okay. And I just wanted to show you something that I think you might find sort of helpful. When we look at this question here, to take away 7, all right. Firstly, I want you to always have the number line in your mind. I want you to be able to picture a number line, all right, and then be able to work out the answer. But I do want to just quickly show you something first before we do that. All right, here's an expression, okay, an expression of a whole lot of integers. All right, and what I want to show you is that we can move things around in this expression. So in other words, if I go and drag on this 2, I want you to watch that the negative sign goes with it. All right. So the sign that matters in terms of that number is the number in front of it. So in fact, what I'm going to do is I'm going to drag that to the end. All right. And I'm going to, now I'm going to drag the positive numbers to the front. Okay. So I'm going to take this 7 and I want you to watch when I drag that 7 to the front. Okay. It actually says, okay, that's the same as putting it over there. All right. Let's drag the 5 next to the 7. Let's drag the 4. It's also got a plus there. All right. And now these expressions are all equivalent. Okay. All right. They're all going to give the same answer. Okay. So if we have a look at this first one, and I'm just going to actually do it, -3 plus 5. Well, in fact, this one here, 7 plus 5, 12, plus 1, 13, subtract 9 is 4. Subtract 1 is 3, subtract 2 is 1. All right. So we can rewrite an expression. This 2 take away 7, we could also think of this as -7 and this then -7 plus 2. Both of these answers are the same. You can tell me what is the answer to 2 take away 7 or -7 add 2?
-5.
-5. Well done. Okay. Right. -5 plus 2.
-3.
Well done. -3 subtract 4.
-7.
-7.
Well done. -7. -8 add 10.
2.
2. All right. And when we write 2, we do not have to write the plus sign here. Okay. We can write the plus sign, but we don't have to. In maths, we tend not to write things that we don't need to write. Now, remember that when we multiply positive numbers by positive numbers, we get positive answers. When we multiply positive numbers by negative, okay, I'm gonna have to mute everyone again, guys. This is really tiresome. Hey? It's very difficult. Okay, because I'm doing this all on my own here. So please try not to. Just you can just unmute yourself, give an answer, and mute yourself again. Otherwise, we hear your cat and your dog and your toilet flushing and all sorts of noise, and it's very hard for people to concentrate. Okay, what I was saying Positive times a positive is positive. Positive times a negative is negative. And negative times a negative is positive. Okay. And so it goes. Okay. So positive 2 times negative 3. Just unmute yourself and give us an answer, someone, please.
Negative 6.
Okay, well done. Negative 6. Great. Now, guys, when we subtract a negative, all right, that is the same as adding. Okay. And I think I'm going to just quickly show you a demonstration of this. Okay. All right. Thank you. I'm going to quickly show you just a little demonstration of some integer sums, just to help you make sense of them. Okay, I'm having to mute everyone again. All right, so I'm going to show you a very short little video. Okay, it's actually from a talk that I gave, but I'll show it to you here. So it's going to take me just a minute to find this. Okay, I just want to show you this little video over here. All right, and so if we look at a question like the yellow counters are positive numbers. Okay, so 2 positives, add in 2 more positives. So when you take positive 2 and you add in 4 more positives, what do you get? You get positive 6. Okay. Now we're going to do a different one. What about 5? That's 5 yellow ones, positive 5. Take away minus 4 yellow ones. All right.
1.
So we're going to take it's going to be 1. Yeah, look at it. It's going to be 1. Okay. All right. Okay. Now let's look at another one. Let's look at positive 2. So that's 2 yellow ones. And now we're going to add in 4 red ones, 4 negatives. Okay.
Yeah.
And now what happens here, guys, is that
Yeah.
a positive and a negative cancel each other out. They form what we call a 0 pair. So that stuff on the left is all 0. What's the final answer?
Negative 2.
Well done. Negative 2, 100%. Negative 2. Okay. Now, negative 3, 3 red ones. Add in 2 more red ones. Okay. So it went a little bit off the screen there. What's the final answer to that?
Negative 5.
Negative 5. Now, guys, this is the tricky one. Okay. 5, I'm just going to pause it here. Positive 5, take away negative 2. Okay, and I want you to see why this makes sense. Maths always makes sense. Isibalo zitaqek injalo. That's isiZulu for the same thing. Okay, right. So what we're going to do here, we're going to put 5 in. Now, we have a problem. All right, because it's telling us to take away 2 red ones, and we don't have any red ones. Okay, what we're going to do, we're going to bring in some red ones and yellow ones together. We're going to bring in a 0 pair. Do you agree that hasn't changed the value? Are you okay? Over there on the table, we still have positive 5. Am I right? Because the red and yellows, those red and yellows are cancelling each other out. They are what we call a 0 pair. But what I now am able to do, I can now take away 2 red ones. Watch. And what's my final answer when I take away 2 red ones?
Negative 3.
Seven.
It's 7, guys. Yeah. So listen very carefully to this. When we subtract a negative, it is the same as adding. Okay, and this is what we've got right here. So 5 subtract negative 2 is actually the same as
7
5 plus 2, and the final answer is 7. Well done. Okay, right. Okay, right. So guys, okay, so just try and mute yourself again if you're not actually answering a question. Okay, right. So now what we're going to do in each case, we are going to write this thing without any extra signs. So in other words, I'm going to write it. I'm not going to don't try and do the question straight away. All right. But here's our little set of rules. Okay. Plus followed by a plus, it goes to a plus. Okay. And that's the same whether we've got a plus followed by a minus goes to a minus. Okay. A minus followed by a plus goes to a minus. And the one that's kind of a little bit unusual, a minus followed by a minus goes to a plus. That little table there, you need to learn. You need to know that and you need to practice it, okay? Negative times a negative is positive. Negative divided by a negative is positive. Or subtracting a negative is the same as adding. A positive times a positive is a positive. Or adding a positive number is just the same as adding. Adding a negative number is the same as subtracting. Subtracting a positive number is the same as subtracting. Okay, so this little table works for everything. Okay, right now, -4 add -2. I'm not going to try and answer the question. I'm just going to write it down without the extra sign. So -4, adding a negative is the same as what? Look at the table. Adding a negative, is that a plus or a minus now? Guys, adding a negative is the same as subtracting.
It's a minus.
It's a minus. Well done. It's a minus. Okay. So now this is better. This is simpler. And what's the answer for -4? Think on the number line. Think where we are at -4 and then subtract another 2. What's the final answer here?
-6. -6.
Well done. -6. Okay. All right. What happens when we divide a negative number by a positive number? What do we, sorry, a negative number by a negative number? Do we get a positive or a negative answer?
Positive.
Positive. And the answer will be,
Not bad, not
the answer will be +3. Okay, I'm going to mute everyone again because it's just getting a little bit noisy. All right. So now let's look at this one. -3 subtract +6. Don't try and answer that question in one go. A question like this in an exam, it can well be worth 2 marks. Okay. If you just write down an answer, let's say, I think the answer is 3. You're going to get 0 because the answer is wrong and you've done nothing right. Okay. Let's suppose you did this. And we'll answer it correctly first. -3. What happens when you subtract a positive? Is that a plus or a minus?
Minus.
Well done. That's a minus. And now there's our answer. That's correct. Okay, now we've got 1 mark. Even now, let's suppose I make a silly mistake and I say -3 subtract 6. The actual correct answer is -9. And that's the part. Okay, let's suppose you made a careless mistake and you said -10. You're still going to get 1 mark for showing this. Okay, or, and I'm just going to do it, I'm going to do it wrong here. Let's suppose you thought that was a plus. Okay, and you wouldn't get that mark. Okay. But you now said -3 plus 6 is +3. You would still get the second mark because you've done something correct, even though you first made a mistake. Okay, so try and show working in maths tests and exams. All right, that makes it easier for the teacher to give you marks when you've made a silly mistake. All right. Now, don't forget, everything in maths is connected to everything else. Okay, so we've also got. And the nice thing about maths is we don't change the rules, okay? When you were in grade 3, you learned about BODMAS, okay? Order of operations. Now we're doing integers. We still have BODMAS, okay? So must I do this operation first or must I do this operation first? Which one, the blue or the green?
Green.
I must do the green one first. I must do the multiplication first. So I'm just going to write this as -3. Okay, now I've got plus. What is 4 times -1? +4 times -1.
What's -4?
It's -4, okay? Now I've got an extra sign here that I don't want. I'm not going to try and write down the answer. I'm going to just remove the sign. When I add a negative, is that the same as a minus or a plus?
Plus.
Look at my little table at the top here. When I add a negative, I'm talking about, it's a minus, yeah. Okay, when I add a negative, it's the same as a minus. And so what's the final answer here? -3, take away another 4.
1.
No, it's not 1. It's not 1.
Negative seven.
Negative
Negative
7.
seven.
Yeah, I can see
Negative
where
7.
I can see where how you might have got 1.
Oh, cool.
Yeah, guys, negative 3 is here, and we're going 4 more that way. Negative 7 is the answer. Okay. All right. Okay. What we must do with this one, we must do what's in the brackets first. Okay. 7 minus 8, negative 1.
Negative one.
Now, guys, I want you just to think about this. What this means negative 1 times negative 1 times negative 1. And I'm not going to write them all, don't worry. Okay. 21 negative 1s multiplying together. Now, 1 times 1 times 1 times 1 is just 1. Okay. But I want someone to tell me, will the answer, and I want you to think about a negative times a negative is a positive. Will the final answer be positive 1 or negative 1? And why?
Negative 1.
Well, that is
Because it's an odd number of-
Negative.
100%.
odd number of negative one.
Because it's an odd
Well done, well done. Okay, guys, I'm going to mute you all again. Okay, I'm going to mute you all again. So 100%, there's an odd number, guys, because watch my hands. A negative times a negative is a positive. A negative times a negative is a positive. But there's an odd number. If I said to you, what's negative 1 to the 210, that would be positive 1. Okay, and the reason now is that there's an even number of negative 1s. All right. Over here, on this next one, must I do the division or the subtraction first?
The division.
The division, okay. And I'm actually going to do the full division here. I'm going to look at this. What happens when you divide negative 8 by negative 2? What do you get?
4.
Well done. You get positive. Look at our little table up here. A negative divided by a negative is positive. So you're actually going to get plus 4. Okay, and hopefully 4 plus 4 is very easy. Okay, right. Here, I must do the multiplication and the division first. Okay, so I'm going to leave the 3 plus here. Now, what is 2 times negative 4? Positive 2 times negative 4. Negative 8. Okay. And what happens when I divide a positive by a negative? 8 divided by negative 2.
Negative 4.
Guys, I'll go and remind you. Here's our table. Positive divided by negative, negative 4. Now, this is better than it was. But still, don't try and go straight to the answer here. Okay? This question's probably worth 4 marks. Because I would give a mark. I'll show you where the marks might come. A mark would come for that answer and for that answer. Now, I'm going to remove the extra signs. Adding a negative is the same as, is that the same as plus or minus here?
Minus.
Yeah, well done. It's the same as minus, and adding a negative, again, a minus. Here's another mark. Okay. Now, the final mark is going to be for the final answer. Think about positive 3, subtract 8. When you subtract 8, what do you get to? You get to negative?
Negative 5.
Well done, negative 5. Now subtract another 4.
Negative 9.
Well done, negative 9. Hala. Okay, right. Okay, guys. So now we've got some square roots, okay? All right, so we want a number that is going to multiply by itself to give us 9, all right? And the answer, guys, don't try and do this all in one go. The square root of 9 is 3. What's the square root of 16?
4.
4. And guys, what mathematical operation is inside here between the 2 and the square root of 16? Is it a plus or is it a times?
Times.
Well done, it's a times. So when I work, I now know that the square root of 16 is 4. Don't write plus 4, okay, because now you've changed the meaning of the sum. don't write the 4 here. Now it's looking like 24. Okay. I'm going to put that 4 in a bracket because it's telling me that I must now multiply the 2 by the 4. Must I do the subtraction here? Must I go 3 minus 2? Or must I do the 2 times 4 first?
2 times 4 because of BODMAS.
Well done. Okay, and negative 2 times positive 4 is negative 8. And now my final answer?
Negative 5.
Negative 5. Okay, well done. Excellent. Okay,
Negative
guys,
5.
just a couple of little things about how you set your work out. In maths, we always work down. Okay, every single thing, one line at a time. And I don't know if you guys have noticed, but every single answer that I've done today, I've underlined the answer. That makes it easier for your teacher to work out what your final answer is. All right. Otandwayo, I see your hands up. Do you want to ask a question?
Where are we? In which question are we?
Okay, I'm at the bottom of page 4, and I'm now looking at this question over here. Yeah, I'm hoping you can see my screen, which, yeah. Okay. All right. Any other questions? I see Chaz, Rodney, or Rodney Chaz. I don't know which way around that is. You've got your hand up as well. Do you want to unmute yourself and ask?
I accidentally put up my hand, my bad.
Oh, no problem. No, that's fine. Okay. All right. Okay. So I see Judith Zuma also got a hand up. If you don't want your hand up, guys, you just click on it again. Okay. So you'll see, like, now I'll put my hand up and I can lower my hand. Okay. All right. Okay. I see what it, yeah. So Otandwayo, maybe you can just tap on the raise and then it'll go away. Yeah. And Judith also, unless you've got a question. Okay. It looks like Melugushe's got a question. Have you got a question, Melugushe?
Sir, can you please
Yes.
explain number?
Or just read the question to me because they haven't got numbers.
4 minus 8 divided by 2.
4 minus 8 divided by 2. Sure. Okay. It's this question over here. Okay. So it's about BODMAS. Okay. We cannot go 4 take away 8 because division has to happen first. Okay. So I'll just redo the sum here with an orange pen. Okay. So basically what we've got 4 minus 8 divided by minus 2. Okay, minus 2 is just a number. You can see that negative is actually a little bit smaller. Okay, so I'm just putting it like that the brackets don't actually change anything here. Okay, but there's 2 operations. I'm gonna highlight the operations. Okay, there's subtracting and there's dividing. All right, and we've got to decide which one of those things are we going to do first. Okay, and we're going to use BODMAS for that. So we must do the dividing first. Okay, so now I'm going to leave that 4 minus 8 exactly as 4 minus. I'm going to leave that. And in a bracket here, I'm going to put the answer to 8 divided by negative 2. Now notice I'm not, at this stage, you can do it in 2 ways. I'm going to just, this minus, I'm leaving as that minus there. So I'm thinking of just 8, positive 8 divided by negative 2. And when you divide a positive by a negative, you get a negative answer. Okay. Positive 8 divided by negative 2 is negative 4. Now I'm subtracting a negative. And right up at the top of the screen here, you'll see our rule for subtracting a negative. When we subtract a negative, it's actually the same as adding. So this is now going to become 4 plus 4, final answer, 8. Okay, now I'm going to do this question again, okay, and I'm going to do it slightly differently. This time I'm going to say, right, actually, so I've got 4 minus 8 divided by minus 2, okay. This time I'm actually going to write the 4 here, and I'm actually going to take the minus 8, and I'm going to divide by the minus 2. Okay, all right. And what's negative 8 divided by negative 2? A negative divided by negative?
4.
Positive 4. Okay. And notice that we get exactly the same answer. So here I didn't take the sign. I kept the sign sort of separate, but it actually all works out in the end. Okay. All right. Now we are looking, I'm going to this last question on this page. We're looking for the cube root of a negative number. So we need, just think about what a cube root means. We want a number that we're going to times by itself 3 times to give us negative 27. Okay.
Cube root of negative 27 is negative 9.
It's not negative 9. It's not, it's not negative 9 because, guys, when you multiply 9 by itself 3 times, you definitely don't get 27. Okay. We remember.
Negative 3.
It's negative 3, 100%. Negative 3 times negative 3 would be positive 9 times another negative 3. Okay, so I've got 4 plus negative 3. Now, what's the cube root of negative 8?
Negative 2.
Well done. It's negative
Negative
2,
2.
guys. It's negative 2.
Yes.
Okay. Now, this is almost like playing a game of golf, okay? Which is a very difficult game. You're trying to hit this little ball into a hole miles away. But is this better or worse? I think it's better, okay? So we've played our first shot and we're a bit closer to the hole. Now, what I'm going to do now, I'm not going to try and answer it, okay? I'm going to ask Sayush if she's got a question. But I'm going to ask, what will this look like if we take out the extra signs? So you just unmute yourself and ask your question.
No, so it's fine.
Okay, cool. All right, just put your hand down if you haven't got a question. And then second in the queue of questions is Judith. Is your hand still up? So Judith, just drop your hand if you haven't got a question. Okay. All right. Okay, so I'm going to mute everyone because it's just quite noisy. All right. Okay, right. Guys, here we've got adding a negative. And remember, adding a negative, that's this line over here. Okay, adding a negative is the same as subtracting. Okay, so instead of writing 4 plus negative 3, I'm just going to write 4 minus 3. Is that better or worse than it was? It's better. It's tidier. Here we've got subtracting a negative. Okay, and I want you to remember those red and yellow counters. When we subtract a negative, we actually end up adding. Okay, so subtracting a negative is the same as positive 2. Now, this is getting better and better. Okay, and the final answer here, 4 minus 3 is 1, plus 2 is 3. I want to show you that you can do that in a different order. I went 4 minus 3, okay, all right. Ugusha is requesting to present. Okay, I'm going to not give you permission to share your screen at this stage because I'm busy teaching. So I'm just going to say no to that. Okay, all right, guys, listen to this. 4 minus 3 gives us 1, plus 2 gives us 3. Another way of doing this, I could say 4 plus 2. What's 4 plus 2? 6 minus 3, we still get 3. Okay, maths makes sense. It always makes sense. Okay. Now we're going to talk about fractions. Okay, I love fractions. Okay, and I'm going to do a very basic thing here, whereby I'm just going to give us a little story here. Okay, so there's a cake. All right, now that cake. Okay, we're going to share it with 4 people. Okay. All right. So, but what I'm going to do is I'm going to share that cake with 4 people. And I'm going to do that in 2 different ways. Okay. The one thing I could do is I could cut that cake into 4 perfectly equal slices. So I'm going to cut it. I've got 2, and I'm going to cut each of these 2 in half. I'm actually not going to do it like that. I'm going to do it slightly neater. I'm going to try and get this to be a straight line. Okay. Guys, it's not perfect. Okay. But hopefully you can see. All right, so those 4 pieces of cake are identical. I'm sharing this cake with 3 friends, okay? This is my piece, okay? Now, another way we could cut the cake up, we could actually cut it into more pieces, okay? This time what I'm going to do, I'm going to cut the cake. Sorry, guys, I want to do this just slightly differently, okay? All right, This is not what I wanted to do at all. Okay. So the first time I cut the cake with the green cuts, I just want to cut it like this. So right, all these pieces are the same size. I know that I look exactly the same size. Gotta love this. Okay. Oh, gee. Sorry, guys. My pen doesn't want to just straighten up. Okay. All right, there it is. Okay. So that's my piece. Okay. Another thing I could do, I could cut the cake into more pieces. How many pieces of cake have I got on the right-hand side?
8.
I've got 8.
8.
Now, if I get one slice here, if there are 8 slices and I'm sharing this cake and I want to have the same portion of the cake, how many pieces must I have?
2.
2. This time I must have 2. Okay. So what we've got here, we've got that 1/4, 1 out of 4 pieces is exactly the same as having 2 out of 8 pieces. Okay. And okay, I'm just muting everyone because we've got children crying in the background. We've got all sorts going on. Okay. All right. Guys, the rule for equivalent fractions, these fractions are equivalent. They have the same value. If I get 1/4 of the cake or 2/8 of the cake is exactly the same. Okay. And the rule for equivalent fractions, all right, and it's the rule for proportion and ratio and everything, is the only thing that we're allowed to do to get an equivalent fraction. I'm going to write it over here, nice and big. We can either times or divide both by the same number. We can't add and we can't subtract. Okay, so the big things that I'm going to highlight here, timesing or dividing both by the same number. All right. So for example, give 3 equivalent fractions to 3/5. Well, I could multiply the top by 2 and the bottom by 2. I could multiply the top by 4 and I could multiply the bottom by 4. These fractions are equivalent. They're exactly the same value. Okay. Jack, have you got a question? Jack Hill? Okay. Yeah, Jack, just put your... Sorry?
How?
Okay, I'm not hearing. Just ask the question if you've got a question. All right, guys, I'm going to do one more. We could multiply the top by 100 and the bottom by 100. I want to show you something that I can do now. On this one that I've got here, I could divide the top by 10 and the bottom by 10. Every single one of these fractions is equivalent, guys. I'm going to take this one, the 6/10, and I'm going to multiply the top by x and the bottom by x. That's another equivalent fraction. That one involves algebra. Okay. All right. Okay, so I'm going to mute everyone because people are talking in the background again. If you've got a question, just unmute yourself and ask it. I see Ayama's got a hand up and Jack Hill also has a hand up. Okay. All right. Guys, so now we want to simplify these fractions. So we want to look, can we find something that goes into both 4 and 14? They're both even numbers.
2.
So absolutely. So let's divide the top by 2 and the bottom by 2. And those numbers, guys, don't have any common factors. Okay, that's the simplest fraction here. All right. This one over here. Okay, I'm going to mute everyone again. Okay. Guys, please try not to leave yourselves unmuted. Okay. I don't know if maybe some of you don't understand how the microphone works. Okay. I'm just going to quickly show you. All right. So there is the microphone. Okay. And you can see my microphone has not got a line through it. All of your microphones at the moment have got lines through them. I can mute myself.
minutes ago.
Okay, now you can hear me. All right, just make sure that you're muted so we don't hear background noise. Okay, all right, guys, this one over here, you don't have to do it all in one go. Okay, so what we can do, we can divide, we can divide the top and the bottom by 100.
Then
Okay.
simplify games, sir. So like to
Sorry?
1/4. Then
Absolutely.
simplify
No.
Can you do it by
We-
10?
Correct. We can divide by 3 and by 3. Okay. These ones, and again, guys, this is going to depend how good your numbers are. All right. You might say, well, can we halve both of these to 24 over 48? You'd be correct. Okay. But if you're good with your numbers, you should know that 48 is actually a multiple of 12. And 96 is also a multiple of 12. If you divide the top by 12, you get to 4. You divide the bottom by 12, you get to 8. This can simplify further, obviously, because we can divide by 4 and by 8. All right. I'm breaking my rule. 1 over 2. We're dividing by 4 and dividing by 4. Okay. Now, I'm going to show you guys just a very short little piece of video here. Okay. All right. Here we go. All right. So here's a pizza. Okay. I don't know who likes pizza. I do. All right. And the question is now, which would you prefer? Would you prefer 2/3 of this pizza, or would you prefer 3/5? Okay. In other words, if we cut it into 3 slices like that, would you like 2 of those slices? Or would you rather have, I'm going to cut it into 5 slices now. Would you rather have 3 of those slices? Okay. And fractions allow us to work out. No, you're actually wrong. Okay. Let's quickly do that. Okay. Yeah.
So are
Let's
they
quickly
equal?
do it, guys. They're not equal. 2/3, 3/5. Okay. Now we want to compare these fractions. So what we're going to do, we're going to make them into the same type. It's very much like, guys, just listen carefully to this. It's very much like if I said to you, would you rather have 300 Rand, okay, or $20? Okay. Now, what you would need to know to answer that question, you'd need to know the exchange rate. But do you agree? You can't compare them because they're different types of things. 300 of one thing and 20 of another thing. And people who don't understand maths are going to say, oh, yes, I'll have this. 300 sounds like a lot. I promise you $20 is actually more like 400 and something Rand. Okay, $20 is actually better. So what we need to do, we need to either change our rands into dollars, or we could change our dollars into rands, or we could even change both of them into some other currency like euros or pounds or something. Okay. Once they're in the same currency, then we can convert, then we can compare them and we can add them. So I want someone to tell me what fraction type do 3 and 5 both go into? What could I change them both to?
15.
15.
15.
15.
Okay.
15.
Now remember the rules, guys. Whatever we do to the top, we must do to the bottom. What are we multiplying the bottom by here? By
5.
By 5.
5. Okay. Now we've got sounds like a chicken rooster crowing or something. Okay. All right. There we go. Muted everyone again. Guys, we're multiplying by 5, so we must multiply the top by 5. Here we're multiplying by 3, so we must multiply the bottom by 3. Sorry, multiplying the bottom by 3, we must multiply the top by 3. Okay. And now they're the same types of things. Now they're both rands, or they're both euros, or they're both pounds. Okay. All right. And now, which one? We can see which one's bigger. If we cut that pizza into 15 slices, would you rather have 10 or 9? And the answer, unless you don't
10.
like pizza, this is the answer, guys. And I'm going to go back here, and I'm going to rewind this. I'm going to rewind this video, and I'm going to show you when we have 3 slices. I want to show you if we start cutting from here, we can have this slice and this slice. We actually get a little bit of that mushroom there. Okay. I'm now going to take it to 5 slices again. All right. And if we have 3 slices, we get this piece, and this piece, and we don't get anywhere near that mushroom that we were getting before. Okay. Does it make sense? it always makes sense. Izibalo, okay, it makes sense. Right, now guys, what we want to do now, okay, and I'm not going to do every question in the book today, okay, but we're going to convert these fractions into the same type to arrange them from biggest to smallest. Remember, biggest to smallest, descending order, okay? And does anybody know what number what's the lowest common denominator of all these 5 and 3? 60. Well,
60.
well done. Well done to the person who said 60. Okay. All right. And guys, I'm just going to very quickly do this. To get 5s into 60s, we're multiplying by 12. So I must multiply the top by 12. To get 3s into 60s, we must multiply by 20. Okay. Just going to finish this question before we have our break. All right. So I must multiply the top by 20 and the bottom by 20. All right. Now, to get 4s into 60s, I'm going to multiply by 15. So I must multiply 3 by 15. To get 2s into 60s, I must multiply by 30. So understand, guys, this fraction here has exactly the same value as that fraction there. All right. And then lastly, to get 6s into 60s, I'm going to multiply by 10. All right. So it's going to be 10 60ths. Okay, now I want to write down the original fractions from biggest to smallest. So the biggest one is obviously the one that's got the biggest number of 60ths, and that's this one over here. So 3/4 is going to be my biggest fraction. I'm going to tick it off. That's 45. The next biggest one's going to be 30. So that's going to be a half. The next biggest one is going to be 24. That's going to be my 2/5. All right, and the next biggest one was at 24. It's going to be my 20. That's going to be a 1/3. And then the last one is 6. So it's going to go 1/3, 1/6. Okay. Equivalent fractions is essential not only for comparing, but also for adding. All right, guys, it's 10:41. In fact, it's actually 10:42. No, yes? It's 10:41. Okay. All right, I'm just going to mute everyone. Okay, right, guys. So I'm going to leave out quite a lot of stuff now. And that's just because we haven't got time to do everything. Okay, now, if you have a look at inserting a fraction between two numbers here, okay? So for example, inserting a number in between 4/7 and 4/8. Now, there's kind of no space, all right? But what we can do is we can basically make these into equivalent fractions. So we would multiply this one by 8. So we would get 32 over 56. That's exactly the same number as 4/7. This one we would multiply by 7, and we would get 28 over 56. All right, and now it's easy to put a fraction in between there. There's actually a whole lot of whole number fractions that could work: 29, 30, 31, 32. The one that's actually right in the middle is obviously halfway between 32 and 28, which is 30. So 30 over 56. And 30 over 56 can simplify, but it's a fraction in between those two. Right, now, I'm not going to spend long on this, but obviously equivalent fractions, okay? We can't add 2/3 and 1/4. It's exactly the same thing as trying to add 3 meters and 10 centimeters. You can't say 13, doesn't work like that. All right, it werkt nie so nie. Okay, so we've got to either change the meters into centimeters or the centimeters into meters, or change them both into something else. Now, it's hard to change thirds into quarters. In fact, it's very hard, and it's hard to change quarters into thirds. So let's find something that they both go into, and a common denominator would be, say, 24.
12.
Okay,
12.
Yes, 12 is the lowest common denominator. What we're looking for, in fact, is the lowest common multiple, and 12 is the best answer. If I want to show you, okay, so I'm going to use 12. I want to show you that if I use 24, I would get exactly the same final answer. Okay, I've multiplied by 8 on the bottom. I must multiply by 8 on the top. that fraction is exactly equivalent to the one above it. Here I've multiplied by 3, I must multiply by 3. All right, so just to reinforce what we're saying here, these green fractions are identical in value. All right, these blue fractions are identical in value. Okay, now they're of the same type, so we can add them. Okay, so I don't know what I've done here. Okay, I don't know where that 16 came. Yeah, I don't know where the 16 came from, guys. Okay, so that's absolute rubbish. All right, I've multiplied the bottom by 4. I must multiply the top by 4. It's actually 8 over 12. Okay, all right, sorry about that. Now we've got the same types of fractions. We're going to add them, and so we get 11/12. All right, just to show you that if I went with 24ths, okay, to get thirds to 24ths, I multiply the bottom by 8 and the top by 8. Okay, so I now get 16/24ths. Here, I must multiply the bottom and the top by 6, and I get 6/24ths. And when I add them, I get 22/24ths. But 22/24ths can simplify because these are both even numbers. So I can divide the top and the bottom. I'm breaking my rule of working downwards just because I've run out of space. I can divide the top and the bottom by 2 and I get the same answer. Okay. Obviously, it's better to use the lowest common denominator rather than a higher one. Okay. Multiplying fractions is really simple. We just multiply the tops and we multiply the bottoms. So this is just going to be 6/15. All right, that can actually simplify because both of these have a common factor of 3. And if we divide the top and the bottom by 3, we get 2/5. Okay, and what you might have noticed is that over here, we could have actually divided the 3's out at the top, at the start, and we would have got 1 times 2 over 1 times 5, which is 2/5. Okay, right. I'm not going to do any more fraction work today. The only thing I'm going to just remind you is that if you don't forget BODMAS, so you might want to try this question yourself at some point. All right, you should try all these questions before you write your exam. Remember BODMAS, but also remember that you do the way we divide fractions. Okay, so I'm going to quickly do this question. Is you tip the second fraction over and you change to a times sign. So this is the same as 2/1. Now we've got 4/5. Okay. A really important idea is that we never multiply, add, or do anything with mixed numbers. So I'm going to change this 4/5. All right. Sorry, this 1 2/3. I'm going to change that to 5/3. Okay. And
Wow.
just to quickly unpack why that is how that is. All right, because I just want to show you that it always makes sense. You've probably learned a rule that you multiply the 1 by the 3 and then you add 2. Okay, let's just look at what 1 2/3 means. It actually means that, all right? And 1 is actually 1/1. As a fraction in thirds, it's actually 3/3. So we're adding 3/3 to 2/3, and that's how we get our 5/3. Okay, now BODMAS, eh? Don't go and start adding these two fractions. We've got to do this stuff. We've got to do that operation and that operation first. Okay, when we multiply fractions, we just multiply the tops and we multiply the bottoms. When we multiply fractions, we multiply the tops and multiply the bottoms. In this case, I actually can see that I could divide the top and the bottom by 5. You might use the word cancel. I don't like that word. It's not a good word, okay? We're dividing by the same number on the top and the bottom. So we actually get 4/3 plus 4/3. And this is really a nice situation because I've got fractions of the same type. So I just add the tops. Okay, right. I am seeing some hands up now. I don't know if these are new hands. Jack Hill's hand's been up for a long time. Take it down if you don't want it up. I'm seeing Luanle's hand up. Either unmute yourself and ask a question or put your hand down. And I'm also seeing Otanduayo's hand up. Okay.
Sir, I have a question.
Great. Go for it.
So, there is this thing called cross multiplication. But like, sir, I'm not sure where to use it, if we use
Yeah.
it in multiplication or in
Okay.
division.
All right. No, you never use. Okay, I'm going to mute. I'm going to mute everyone. I have heard the question. All right. Cross multiplication is actually, in a way, it's quite a bad idea. It's when we're solving equations. All right. So if you've got an equation, okay, I don't really want to get into this now. All right. But if you've got an equation, so an equal sign, then you can get rid of, if you've got one fraction on each side, then you can multiply that by that, and it'll be the same as multiplying that by that. And I'm just going to show you, for example, if you've got 4/10, 4/10 is equal to 2/5. I think you would agree. Okay. If you go this times this, you get 20. And if you go this times this, you get 20. So over here, 3 times x would equal 8. That's where we kind of cross multiply to get rid of fractions. But when we multiply fractions, we never cross multiply. We multiply the tops and we multiply the bottoms. Okay. All right. I'm going to leave fractions. I'm also going to leave this decimal stuff. Okay. I'll do literally 1 or 2 questions. Okay. This as a fraction in its simplest form, we read to how these are. Straight after the decimal point is tenths and then hundredths. This is 64 hundredths. Okay, and it's really important that you can understand that, which is obviously also 64%. Okay, 64 hundredths as a fraction in its simplest form, that's not in its simplest form. Okay, because we could divide the top and the bottom by 4. All right, and if we did that, we would get 16 over 25. All right, and 16 over 25, that fraction is in its simplest form. Okay, and there it is. Okay, this one over here, the 2 is actually in the tenths, hundredths, thousandth column. So this is actually 2 over 1,000. 2 over 1,000 is not in its simplest form. All right, because we can, forgot to underline that answer, we can divide the top and the bottom by 2 and we get 1 over 500. Okay. Taking a fraction to a percentage, well, we want to get 100 on the bottom here. All right. So to get 100 on the bottom, we must multiply the top by 10 and the bottom by 10. 30 out of 100 is the same as 30%. Okay. So I'm not going to do loads and loads of these. I am going to do these C and D just because they're really important questions. Okay. So a shopkeeper offers a 20% discount. Okay. What does an item that costs 300 Rand now cost? Okay. So the way I like to do this, all right, and I do this with all the proportion type questions, and we're going to get into some of these now. All right. I write down that 100% is equivalent to, and I write 3 lines there, 100% is equivalent to 300 Rand. Okay, now I want to know what 80% is, right? And so it's not, remember what we said earlier, and I'm going to just scroll up and show you, because exactly the same thing happens here. Okay, guys, let's have a look at this. We can times or divide both by the same number. Exactly the same thing happens here with this proportion. Now, I don't know what to do to 100 to get to 80, but how do I get from 100% to 1%? I've divided here by 100. And remember, I must do the same thing on both sides. So if I divide here by 100, all right, I actually get 3. All right. So 1% is 3 Rand. How do I get from 1? And remember, I can only multiply or divide. How do I get from 1 to 80? Well, I'm going to multiply by 80. All right. And if I multiply by 80 here, I've got to multiply by 80 here. And so 3 times 80, the final answer is 240. 80%, because if we offer a 20% discount, we're going to pay 80%. Okay. Let's look at another example. A shopkeeper marks up by 15%. What does an item which costs 240 Rand cost after the markup? So we want to work out, we know that 240 Rand, doesn't matter which side we put which, 240 Rand is equivalent to the full price. Okay. Now the shopkeeper is going to add on 15%. So I want to know, what is 115%? Okay. All right. And all I'm allowed to do is multiply or divide the same by both on the same side. Now, it's not obvious what to do to 100 to get to 115. But what is obvious is how I could get 1%. All right. Remember, I can only multiply or divide. The way I could get 1% is to divide by 100. But if I divide by 100 there, I must divide by 100 there. Okay, so 1% is actually the same as 24 Rand. Not 24 Rand, 2 Rand 40. Okay, and now how do I get from 1% to 115%? I'm going to multiply both sides by 115. Okay, times 115 and times 115. All right, and I'm going to quickly pull up a calculator to take my 2 Rand 40 times 115. Okay, and I get 276 Rand. Okay, this for me is the easiest way to do these questions. And I'm going to do another question like it. Okay, all right, so I'm going to leave some stuff out. Just wondering if I've got a question like that. No, actually, as it turns out, I haven't. Okay, I haven't got another question like that. Okay, but if we had exchange rates, dollars to rands, if we had liters of diesel costing so many rands, we can solve all these questions using this method. Okay, all right. We're going to talk very briefly about exponents. All right, just remember what exponents mean. It means that we just 3 to the power of 5 means multiply 3 by itself 5 times. 1, 2, 3, 4, 5. Okay, now if we look at something like this, all right, common error would be to try and multiply these two 5s. You can't do that. Okay, but all of this makes sense. Okay, what we've got here, how many 5s have we got multiplying together over here? How many are there? There are 12 5s.
12.
Okay, and then how many are over here?
7.
Okay, and then so then we're multiplying another 7 5s. So what we've actually got is we've got a whole lot of 5s multiplying together. How many 5s have we got all together multiplying together?
7. Oh,
No, we've got 12 and another 7.
19.
19. And guys, the short way of writing 5 times 5 times 5, 19 5s is like that. So I'm hoping that what you realize is that we just add the exponents. We add the little numbers at the top. I'm going to just do an example here. If I said to you, 2 to the power of 40 times 2 to the power of 20, right? We don't want to write out all these 2s and all these 2s. How many 2s are there all together multiplying here? There are 60. Final answer, 2 to the power of 60. A lot of learners say to me, Paul, isn't 2, I learned that 2 times 2 is 4. Okay. But this is not a normal 2. This has got an exponent on it. Okay. 2 times 2 is 4, but this is not a normal 2. All right. So if I look at this question over here, all right, let's look. Okay. All right, there are quite a lot of hands up, guys. You're welcome to just unmute yourself and ask a question. All right, the hands up thing doesn't really seem to be working. I'm not sure why. All right, but just unmute and ask a question if you've got a question. Okay.
Sir,
Yes.
Are we doing graphs?
Yes. We're doing everything. Okay. We're doing everything. And that's why I'm leaving out quite a lot of stuff because I'm really trying to focus on the bigger pieces. Okay. All right. Guys, I'm only going to do one more exponent question here, and it's this one. All right. What we've got to be careful about, all right, we want to collect the ones that have got the same bases. Okay. So on the top and on the bottom, I'm going to write down what exponent am I going to get on these threes. Okay. 3 and 3. On the top, how many threes have I got all together multiplying? I've got 9, guys. There are 5 there. No, there are 5 there, and there are 4 there. Okay. On the bottom, I've got. Okay. On the bottom, I've got 1. And I've got 4. So on the bottom, I'm just muting everyone. So on the bottom, I've got 1 and I've got 6, so it's 7. All right. Now I'm going to do the same with the 2s. Okay. So this is, I've got some 2s here. I've got some more 2s here. I've got some more 2s here. I've got some more 2s here. All right. So with my blue pen, I'm going to do the 2s. 2. I'm just going to have to mute everyone again. Okay. Muting everyone. Okay. What I don't want to have to do, guys, is to mute you so that you can't talk at all. I can do that very easily, but I don't want to do that because then it's only me talking. All right. We've got 6 2s here. We've got 11 2s here. That is 17 2s. On the bottom, I've got 11 2s. Now, we can't combine these things, guys, because they are different types of things. Okay. But what we do have, if we think about, and I just want you to think about this, if we had.
Can you please slow down?
Yeah, I'll try and slow down a little bit. Okay. All right. It is being recorded, so you will be able to watch the recording again afterwards. Okay. And then you can obviously pause it, and that will go as slow as you like. On YouTube, you can also play it slower as well. You can play it so I talk slowly. Okay. All right. Guys, I just want to show you what happens. I want to show you what happens with subtraction. Okay. With division, rather. If we had, guys, if we had something like 3 to the 8 and we divided by 3 to the 3, just listen to this. Okay. What we've actually got, what does 3 to the 8 mean? It means 3 times 3 times 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. One more, 8. Okay, I'm going to put little dots here just to show that these are not. This is not 3 million. It's not a number with a whole lot. Okay, and on the bottom I've got 3 times 3 times 3. It's not 333. It's 3 times 3 times 3. Now, watch what I'm going to do. Remember, going back to our equivalent fractions. Okay, and I'm going to quickly go and remind you. The only thing you're allowed to do is multiply or divide both by the same number. So let's divide by 3 on the top and on the bottom, and those go in once each. Okay, let's do that again. Divide by 3 and divide by 3. I don't like the word cancel. I'm dividing. I can do that once more. Okay, and so now what's the final answer? How many 3s are left? There are 5 3s left.
5.
Okay. All right. Now, I want you to realize that what happens here is that we actually, I hope, guys, listen carefully to this. I hope if I asked you to do 3 to the 100 divided by 3 to the 97, I hope you don't have to write down all those 3s. I want you to think about there are 100 on the top, there's 97 on the bottom, and we're going to cross them out one at a time. We're going to divide by 3, divide by 3. How many will be left? 3. There'll be 3 left. The answer will be 3. 100%. So now let's go back to this question here. On the top, I've got 9 3s. On the bottom, I've got 7 3s. I will end up with 2 3s. Okay. 9 on the top, 7 on the bottom. I have got 17 2s and I've got 11 2s. If I cross them out, top and bottom, top and bottom, top and bottom, I'm going to get 6 2s left. And that's my final answer. All right. Okay, I'm going to leave the exponent stuff now. All right. I'm also going to leave the number pattern stuff. I want to get into some algebra, okay? Because this is very, very important stuff. Okay. So let's just look here. This is a function machine. So we're now on page 10. All right. And what this machine says, multiply by 3 and then subtract 1. So let's do a nice easy one first. What happens when we multiply 2 by 3 and then subtract 1? What do we get?
5.
100%, 5. What happens when we multiply 3 by 3 and subtract 1? We get 8.
8.
Okay. What happens when we multiply -4 by 3 and then subtract 1? Do you see how we can't do this if we don't know about our integers?
-1.
No.
Negative 11.
No.
What?
Multiply -4 by 3 and then subtract 1. What's -4 times? Yeah,
11.
-13 is our final answer because this is -12 minus 1, -13. Okay, right. Now, guys, listen carefully to this because what I'm going to tell you now is going to be helpful for us in solving equations. I want to go backwards now. I want to work out what number must I put in to get 31 out. Now, listen carefully. Okay, I'm just going to mute everyone again. It's really annoying to have to do that all the time. Okay, guys, listen carefully. Multiply by 3, then subtract 1. Now, if I want to undo that, I'm going to undo it backwards. Okay, so listen carefully. Times by 3, then subtract 1. I'm going to go backwards. I'm going to add 1 to undo it. And I'm going to then divide by 3. Okay. All right. Multiply by 3 and then subtract 1. Okay. This one over here, I'm actually going to change so this doesn't work out very nicely at all. All right. So I'm going to add 1. I'm going to add 1 and then I'm going to divide by 3. All right. Add 1, I get 30. Divide by 3, I get 10.
Yeah, go
All
on.
right. Okay, I'm just going to mute this person because they keep talking to someone else. They're not part of this meeting. Okay. All right, guys, and the same here. I'm going to add 1 and I'm going to divide by 3. Add 1, I get 60. Divide by 3, I get 20. We can work forwards again and check, does that work? Yes, it does. What I want to do now is I want to write this using a variable. And so what the thing is saying is multiply by 3 and then subtract 1. So when we say multiply x by 3, who can tell me, how do we write that?
3x.
3x, well done. Okay, guys, 3x means 3 times x. Okay, notice that I write my x's different to the times signs, and then I want to subtract 1. Okay. All right, I've got to mute everyone again. Yeah, guys, I'm spending more time muting people than I am teaching maths, which is really frustrating. I don't know if you don't understand. I don't know. Okay, guys, I'm going to have to just. All right, I'm going to unfortunately. Okay, I'm going to mute everyone. Okay.
Can I ask God to
Okay. All right, guys, I've muted everyone, and now you'll see you can't unmute yourselves anymore. Okay, which is a pity. Maybe we'll try again just now. All right, because I really want you to be able to kind of participate. Okay, so now I've muted you all. If you've got questions, type them into the chat. All right, it's just that we've got too many distractions. Okay, all right. Okay, so guys, when I work backwards, all right, listen to what we said. We multiply by 3, then subtract 1. When we work backwards, we're going to add 1 and then divide by 3. Now, I want to show you how we could write this. We could write it like this, and we would be wrong. Okay, and the reason we'd be wrong is that, remember, BODMAS says, actually, this would be 1y plus, and we do the 1 divided by 3 first. So this would now be right. Okay, but all right, I can also write it like this, y plus 1 divided by 3. Okay, we're going to move to another example involving algebra and number patterns. All right. So here's a picture. Boosie's making patterns out of matches. Okay. In pattern number 1, how many squares are there? Well, there's 1 square. In pattern number 2, how many squares are there? There's 2. This is quite easy. In pattern number 3, there would be 3. In pattern number 4, we don't know. We haven't drawn it, but there would obviously be 4 squares. Okay. In pattern N, now guys, what I want you to notice is that this number is just exactly the same. So if we had to draw the nth pattern, and that's a variable, all right, there would be n squares. And if there were p squares, it must be pattern number p. All right, so that's very, very easy. Okay, slightly harder is to look at how many matches are being used. In pattern number 1, we're using 4 matches. In pattern number 2, we've got 1, 2, 3 extra matches. So we've actually got 7. Okay, and in pattern number 3, we've got the 7. We've got we had 8 matches. All right, so we had 7 matches. Okay, and now we're adding in another 3. We've actually got 10 matches. Okay, we can quickly count them just to check. All right, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we've definitely got 10 matches. All right, so now what rule can we see? It looks like we are adding 3. Okay, so I think if we drew pattern number 4, we would have 13 matches. Okay, so now what we need to do is we need to try and work out some sort of a rule. All right, and it looks like these are growing by 3. So what we're going to do, all right, so I'm going to write this here, growing by 3. So what we're going to do is we're going to take our pattern number, all right, and we're going to multiply it by 3. So I'm going to go 3 times pattern number. All right, and if I do that, I get 3 times 1, I get 3. All right, and if I go 2 times 3, I get 6. If I go 3 times 3, I get 9. So it looks like I need to take 3 times my pattern number and then add 1. Let's just check that, guys. 4 times by 3, add 1. 3 times by 3, add 1. Yes, so we've worked out the rule here. We're going to times by 3 and add 1. All right, so now I want you to think again, working backwards. Listen carefully to this. Multiply by 3, then add 1. We're going to subtract 3 and then, subtract 1 and then divide by 3. So if we take 31 and we subtract 1, we get 30. Divide by 3, we will get 10. All right, and we can check that that works forwards again. All right. Now, obviously, we do know that the pattern number and the number of squares is the same. Okay. How are we going to write this rule here now? If we've got our pattern number of n, well, remember, we take 3 times the pattern number and then we add 1. Okay. All right. It is being recorded. This session is being recorded. And obviously here we take 3 times the pattern number and add 1. And then how do we write algebraically to go backwards from the pattern number to the number, from the number of matches to the pattern number? We're going to subtract 1 and then we're going to divide by 3. Okay, and notice, sorry. It's M matches. So I take my number of matches, I'm going to subtract 1 and then I'm going to divide by 3. Okay, and remember that these two numbers are always the same. So this would be M minus 1 divided by 3. Right, we're going to move to another example, some more algebra, all right, and that's this one over here. Okay, so here we've got burgers cost 8 Rand and chips cost 3 Rand. Okay, so remember these cost 8 Rand each and these cost 3 Rand each. Okay, so obviously here I would spend 8 Rand on burgers and I would spend 3 lots of 3 Rand, 9 Rand on chips, and I'd spend 17 Rand. Now this is number, this is not algebra, okay? All right, and I'm not going to do the next row because it's very straightforward, but if I spend 33 Rand and I know that I bought 3 burgers, all right, then I in fact know that I spent 24 Rand on burgers, okay, which means I must have spent 9 Rand on chips. So can I fill in the number of packets of chips here? Yes, I can. 9 rand, but that's not the number of packets of chips. I must have had 3 packets of chips. Okay. Now, what we want to do is we want to do the same questions with algebra. Okay. All right. Okay. So people are asking when the next break is, guys. You need to try and keep focused. All right. I'll tell you when the next break is because I set a reminder on my phone. It's in 8 minutes time at 11:21. Okay. All right. So let's look now. If I buy B burgers and C packets of chips, what's the algebra for that? In other words, how would I work out the total price? Well, I need to take B and I need to multiply it by 8. I don't write B8, I write 8B. We write the number first and then the variable. And then I need to add, all right, I need to add 3C. Okay. All right, I'm reading some questions and people saying they don't understand. Okay, and I'm not sure if it's a specific question. If it's a specific question, then say I don't understand question D or whatever. All right, but basically all we're doing here, we're doing algebra here. Okay, we're doing algebra, and all we are doing here. Notice that these variables have replaced the numbers. Okay. All right. So this we can't do it all, but this here, if I knew the total price and I knew that I'd bought C packets of chips, how many burgers did I buy? Okay. And we let's have a look at these, and I'll do this nice and slowly. Let's have a look at these 2 lines. Okay. Because these 2 lines are exactly the same. All right. The top one doesn't involve variables in algebra. All right. The bottom one does. Okay, but let's look first at how would you work out the bill? How would you work out how many burgers you bought? All right. If you spent 39 rand and you bought 5 packets of chips, and you guys could work this out. I know you could work it out. Okay. What you would do is you'd work out this number over here, the number of rands, and that number of rands would be 5 times 3. Okay. And then you would say, okay, we've got our 39 rand minus 15 rand. That's not the number of burgers. That's how much I spent on burgers. Okay. This happens to be 39 minus 15. It happens to be 24. What must I do to this number to get the number of burgers? I must divide by the price of a burger, okay? And a burger we know is 8 rand. So do you see those numbers there? All right, and we actually get a final answer here of 3. All right, so I'm hoping it makes sense because it's numeric. You should be able to do this, okay? If you're any good with number, you should be able to do this. All right, chips cost 3 rand each, burgers cost 8 rand each. If I know how many chips I bought, and I know my total price, I can work out backwards to how many burgers I bought. Now, let's have a look at exactly this one. Now, this one is where you're all going to say, I'm confused, okay? I'm expecting this, all right? Because this is algebra, guys, right? But all that P represents is the price. C represents the number of packets of chips. So what did I spend on chips? Okay, and the answer to that is going to be found by multiplying C by 3. We could write it like this, C times 3. Do you see that the C has just replaced the 5 from the blue example above? We've got a shorthand way of writing C times 3. We write 3C. That means C times 3. Okay, now remember what we did up here. We took the total price and we subtracted how much we had spent on chips. What we've got there is the number of rands. Well done, Taylor Lee. All right. We've got the number of rands that we've spent on burgers. Okay. That's not the number of burgers. That's the number of rands we spent on burgers. What did we do last? The last thing we did previously is we divided by 8 because each burger costs 8 rand. Okay, and there's exactly the same question, same answer. The bottom line we've done with variables. The top line we've done with algebra, well, with numbers. Okay, all right. Okay, so algebra is just numbers being represented by what we call variables, by letters. Okay, so we're going to just look at a couple of examples here. The number of learners in a class if there are B boys and G girls. Okay, now you might say, Paul, I don't know what B and G are. All right, let's put numbers in here. If this was 7 and this was 3, I think everyone would know the answer. All right, okay. Everyone would know the answer. And the answer would just be 7 plus 3. So if it's B and G, the answer would be B plus G. Okay, I see Ruth's confirming where the recording will be. Okay, and she's showing you. All right, okay. Now, the number of days in W weeks and D days. Now you say, oi, put numbers in, guys. Put numbers in and see what you would do with the numbers. If I told you 3 weeks and 2 days, would you know how to do that? I think you would. All right. You would change the weeks into days by, what do you multiply by to get from weeks to days? You multiply by 7. Okay. All right. Okay. Leave the, I see people saying you don't understand the burger thing. Okay. Guys, we've kind of got we've got a bit of a choice here, because if we go very slowly, all right, then we're not going to get further. Okay. All right. I will try and take questions. So leave the burger thing. You're going to maybe need to look at it again when look at it again slowly with the video. All right. Someone's asking, why is B7 and why is G3? I just made those numbers up. B can be anything. All right. But how do you get the total number of learners? Well, you add the 2 variables. Okay. So just B plus G. All right. Here I'm doing it. Guys, the reason I'm doing a numerical example, and I've just made up the numbers. I've said, let's let W be 3 and let's let D be 2. Can anybody tell me what the number of days is if you've got 3 weeks? Just type it into the chat. Well done. Okay, I've got it there from Herman. Okay, Herman has said there would be 23 days. Okay, and he's absolutely right. And what Herman has done, he's taken 3, he's multiplied it by 7, okay, and then he's added 2. Now, what we're going to do, we're going to do exactly what Herman did, okay? We're going to, and well done, Utandwa has also got 23. We're going to do exactly what Herman did, but we're not going to put 3. We're going to put the variables in their place. So instead of writing 3, I'm going to write W. And instead of writing 2, I'm going to write D. Okay, I'm going to undo that because it's looking a bit untidy. But look at it. It's W times 7 plus D. It's going to be 7W plus D. Okay, 7W plus D. The numbers that I put in there were just to help us get to help us work out how to do this. Okay. All right. So the answer is 7W plus D. Okay. So there's people asking, can we do geometry? Yeah, guys, the reason your mics are disabled, all right, is because the whole time I'm just hearing background noise. Okay. We'll try again. I'll let you unmute yourselves. Okay. But I promise you're going to see what's going to happen. All right. Okay. All right, there's just too many people in the meeting and too many people who maybe don't understand how the microphones work. And yeah, so unfortunately, it's just is kind of what it is. Okay. All right. So how many minutes would we have in D days, H hours, and M minutes? Okay. So again, I'm going to help us do this by thinking numerically first. Okay. I'm going to say 1 day. And I'm going to say, in fact, I'm going to say 2 days. And I'm going to say 3 hours. And I'm going to say 4 minutes. Okay. Now the minutes we already know. Okay. So at the back here, we're going to have plus 4. How many minutes are there in 1 hour? There are 60. So what must we do to the 3 hours to get it into minutes? We must multiply it by 60. Are we okay? All right. How are we going to get days into minutes? I think we're going to need to take our 2 days. We're going to multiply by 24 hours. All right. And then we're going to multiply by 60. All right. Because this is going to be how many hours? That piece is going to be hours, and then multiply by 60. And then we need to add all these things up. Okay, so if we look at this, all right, we've basically got 3 bits. And I'm now going to write this down, but I'm not going to use the 2 and the 3 and the 4. I'm going to use the variables. I'm going to take my number of days. I'm going to multiply by 24 by 60 times 24 times 60. I'm going to take my number of hours, which is not actually 3, it's actually h. So I'm going to multiply h by 60. And then I'm going to take my number of minutes, which is not actually 4, it's actually m, and I'm going to add that at the back. Now that's our answer. Obviously, we can tidy it up. And by tidy it up, I'm going to work out what 24 times 60 is. Okay, I would normally try and do that in my head, but I'm a bit exhausted, so I'm just going to do it on a calculator. It's 1440, and so it's d times 1440. But with algebra, we write the number first. That means 1440 times by d. Then our next term, okay, notice that's a term. Our next term is going to be h times 60, but we don't write it like that. We write 60h, and then our last term is just m, and that would be our answer. Okay, guys, and I know you're finding this hard, okay? But it is actually the essence of grade 8 maths, okay? If you've got a question, you're welcome to unmute yourself and ask it, okay? I know a lot of you might say, oh, Paul, will you slow down, okay? We're going to take a break now, all right? Because we're going to look at some simplification of algebra, okay? All right? When we come back.
Maybe.
Right, guys, we are carrying on.
Come back, pa.
Okay, so I'm just muting everyone there. Right, so again, I'm just going to look at a couple of each sort of type of question. One of the things we need to be able to do is we need to be able to work out, evaluate, find the value of an expression if we know the values of some variables. Okay, and this again links into our integer work, because I'm going to do this one here, 3y minus w. So what does 3y mean? It means 3 times by the value of y. And in this particular case, we've been told that y is actually equal to 3. So you see, we've got a problem now because someone's
No, I apologize.
No problem. Okay. All right. So what I want you to understand is that 3 is just being substituted in. It's being put in for w. For y. Okay. All right. And now I'm going to write down minus w. Okay. And w, remember, is -2. So just be careful. That minus is the minus from there.
Oh.
And now we've got -2. All right. And -2 is actually the value. I'm going to just use a yellow pen here. That's the value of w. So I've put the value of w in there, and that minus sign that was there is there. Okay. We've now changed this from an algebraic thing to a numeric thing. Okay. And it'll be easy now, providing we know what taking away -2 is. Okay. Right, please keep yourself muted unless you've got a question, in which case you're welcome to unmute yourself and ask a question. 3 times 3 is 9. And remember, subtracting a negative, remember our integer work from earlier is actually the same as 9 plus 2. And our final answer is 11. Okay. All right. We're now going to work with some algebraic expression stuff. All right. And it comes back to exactly what I said to you earlier. The sign in front of a number is the sign that goes with it. In other words, when I'm looking at the 2a's, I'm going to write this expression in alphabetical order. I'm not going to change its value. What's important with the two A's is that they are in fact negative. So I can write this as negative 2A. I'm going to start with the A's. Now I'm going to go to the B's, all right? And I'm going to look at the sign in front of the B's. And those are in fact plus 2B's. So negative 2A plus 2B. The next letter after B is C. Okay, and I've got positive 4C's. Then I've got my D's, all right? And my D's are negative. There's actually negative 1D. I could write it like this, negative 1D. Okay, the microphone, you are able to unmute yourself. Okay, all right, at the moment, okay. Well done to the person who got the previous question right. That said the answer was 11. Well done. Okay, so now the D's are negative D. The E's are plus 5E. Okay, and then the F's are minus 3F. This expression is exactly equal to the one above. We've just written it in alphabetical order. And really the only thing that you need to take away from that is what happens is that the sign in front of the term, this is called a term, all right, is what really matters. Okay. So just a few, this is just terminology here, but okay, this expression here has actually got 1, 2, 3, 4 terms. Okay. The degree is the highest power. So the highest power we've got is 3. The constant term, constant means not changing. One of those 4 terms does not vary. It does not have a variable in it. Obviously, yes, you can leave and come back once you've sorted out your technology. Whoever was asking that. All right. Which term does not have a variable in? Well, 7. That's a constant. 7 is a constant. It's a number. 7x is not a constant because it will vary. Okay. The coefficient, when we talk about coefficient, we're talking about the number in front of. Okay, the number in front of x cubed. Okay, all right, and the number in front of x cubed is negative 6. So the answer there would be, yeah, I'm seeing an answer, someone said 6. It's actually not 6, it's actually negative 6. Okay, and then it asks us to rewrite this in descending powers of x. In other words, from the highest power of x down to the lowest power of x. The highest power of x is negative 6x cubed. Then we're going to do the x squareds. And are these x squareds positive or negative? They are positive, so it's plus 5x squared. Then we're going to do the x's, and the x's are plus 3x. And then lastly, we're going to do the term that's got no x's in. And so this expression here is exactly the same value. It's the same expression, just written in a different order. Okay, now we're getting into the crux of some algebra. And the big thing with algebra, guys, is that you cannot add things that are unlike, okay? And I'm just going to sort of just give a little kind of story here. If I said to you I had 3 apples, okay? So here they are, 3 apples. Okay, and then I had plus 2 bananas, okay? And I'm just going to draw a banana kind of like that, okay? I can't add those things, all right? I cannot add them. They're different, okay? If someone else said, okay, I'm going to give you some more apples. I'm going to give you another 4 apples. And I'm going to give you another 3 bananas, okay? I can add the things that are like. I can give a final answer for like how many fruits I've got here. Okay, what I've got 7 apples and 5 bananas. Okay, so we can only add things that are the same type of things. Okay, and this is a really big idea. Okay, and I've already seen correct answers there. Well done for this one. Okay, 2x. I can't add 2x to 5y, but what I can do is I can add this term to this term because they're the same type of things. Okay. And when I add 2x to 3x, not surprisingly, when you add 2 apples to 3 apples, I'm going to get 5x. Okay. I can also add the other two terms because they are what we call like. So I've got a total of 5x and I've got a total of 9y. Okay. All right, so there's a lot of stupid stuff going on in the chat here in terms of people kind of not really focusing on the maths, focusing on talking to each other. Okay. All right, guys. So I'm giving up my Saturday morning. I know you are as well. Okay. I'm giving up my Saturday morning to try and help you guys. So I'm hoping that many of you are benefiting from this. Let's look at this one. Those three things are like, so we can add them. We can't, however, add in the y's. So we're going to get 3x and we're going to add 2y. Okay. Right, now, this is the nice thing about maths. The rules always apply. Bod maths still applies. So look at this next one. Be careful here because we need to check what must I start with. And in fact, I must start with multiplying these a's together. Now, what is the short way of writing a times a times a? And it's not 3a. What is it? Can anyone unmute themselves and tell me what? Well done. It's a to the power of 3. We use an exponent. Okay. Well done. Okay. Mute yourself again, please, once you've answered. That's great. And at the front here, we've got an a added to an a added to an a. The short way of writing that is 3 times a. Okay. All right. And there's our final answer. You cannot add a's and a cubes because they are not the same things. All right. Now, let's look at this one. This is just a whole lot of t's multiplied together. 1, 2, 3, 4, 5, 6, 7. What's our shorthand for writing 7 t's multiplying together?
A to the power of 7.
Well, t to the power of 7, 100%. Cool. Well done, guys. Please mute yourselves again. Excellent. Okay. All right. Now, I hope you all know that 3 times 4 is 12. But also, 4 times 3 is also 12. So the order in which we multiply numbers does not matter. Okay, so if I look at this question over here, this term over here is actually like with that term over there. You might say, Paul, doesn't look like it's like, but it is like, all right, because I could write 6AB. I could change that to 6BA. I could change to 6AB. Those terms are like. So if I add the two terms that are like, the ones with green underlines in, I get 9AB. Then I've still got the 4A and I've still got the 2B, and I can't add those. Those are unlike. Okay. This next one over here is like a little bit tricky, okay, because it's got all sorts of things here. Remember, the order doesn't matter, but the sign pattern does. Can anyone tell me which term is actually a like term to that 2a squared b? Which of the other three terms is actually like?
4ab squared.
No, not 4ab squared.
5b squared a.
5b squared a.
No. Guys,
It's
they're not
3ba squared.
Yeah, hala. It's 3ba squared. All right, and guys, the reason it's look at
Why is not 4ab?
Okay, it's not 4ab squared because there, I'm telling you now, just listen. Okay, there we've got 1a multiplying with 2b's. That's what that means. This one, we've got 2a's multiplying with a b. And this one, we've got 2a's multiplying with a b. These two here are actually like, because we've got 2b's multiplying together with an a, and here we've got 2b's multiplying together with an a. Those two green terms are like, and the yellow terms are like. All right, now we can add like terms. So if I've got two things and I get given 3 more of them, I've got 5a squared b. We normally write in alphabetical order. So notice this one, I'm seeing it as an a squared b, even though it's a ba squared. And that's because multiplication you can switch the order. Okay, here I've got 5 of these things and another 4 of them. So altogether, I've got 9 of them. The normal thing would not be to write b squared a, but to write the a first. But the b, remember the squares on the b. I cannot go any further with this. These are unlike. Okay. Now, we've got a law of mathematics that makes perfect sense, and it's called the distributive law. And what it means, distribute, means to share.
Sir?
So yeah. I'm trying to watch the chat as well, guys. Obviously, it's on a different screen here. I've got 2 screens going. Yeah. I am like terms can add, and unlike terms don't add. Okay. All right. Okay. So distribute means to share. So, guys, if I asked you to double this number, double the number 7, you would all be able to say, oh, it's 14. Okay. But if I wrote it like this, and I said double this sum, which piece must you double if you want to get the right answer? Must you double the 3 or the 4 or both?
Both.
Both, 100%. You must double the 3 to get 6, and you must double the 4 to get 8. And you'd still get the right answer. So look at what's happening here. We are multiplying this term, this expression by 2. Each piece must be multiplied by 2. 2 must multiply by a, and 2 must multiply by 3b. 2 times 3b, 6b. Can I add these? No, I can't add these because these are unlike. Okay, so I see Herman said 2a plus 3b. No, Herman, you've got to multiply the 3b by the 2 as well. Okay, all right. So the thing, I'm going to do another example here, okay, just because.
So,
yes.
so isn't there 1 in front of the A?
There's a 1 in front of the A, absolutely. So it's 2 times 1. Okay.
Oh.
2 times 1. 2, okay. All right. Guys, have a look at this. Okay. This 3 must multiply by this term, and it must multiply by this term. Okay. So 3 times 5x. Anybody want to just tell me what's 3 times 5x? Or anybody want to tell me the final answer for this one?
15x
It's 15x, and then what?
plus 2.
Plus
No,
6.
not plus 2. Plus 6. Plus
Plus
6.
6.
Plus 6.
Okay.
Plus 6.
All right, great. Just mute yourselves again, guys. 15x plus 6.
21.
That's correct. Okay. Not 21. Okay. All right. I'm pleased you said it, even though it's wrong. You cannot add 15x and 6. They are unlike things. That's like adding apples and bananas. Okay. We stop there. Okay. Now I'm going to do these 2. Okay. I'm going to do this one first. Okay. Because this one's a little bit easier. All right. Don't be scared when you see like a big sum. Okay. Just let's take it one piece at a time. This 4 must multiply with this x, and it must multiply with this 2. This minus 3 must multiply with this x, and it must multiply with the minus 1. I'm going to ask someone to unmute themselves, and I'm going to ask them if they can just tell me the answer just for that first orange piece.
I can tell. So.
4x
I
plus
can.
8.
4x plus 8.
Well done. 4x plus 8, 100%. That's the answer for that orange piece. Now, and I want you to be very, very careful, because now we need to think about our integers as well. I want someone to give me the answer for the blue piece, and we're multiplying a negative 3 in here. Okay, so what will it be?
Negative 3x minus negative 3.
So it's negative 3x, you're right. When you multiply a negative, no, not plus 1. We've got to multiply this negative 1 by a negative 3. What happens when you multiply?
3.
Oh, well done, positive 3. Okay. All right. Now.
Plus 3.
Okay, just mute yourselves again, guys. This is correct. Okay, but it's not complete because I've got some like terms. I've got some terms that I can combine now. Okay, and I like to use color. So I'm going to put some color in here. Those two terms are like, they're the same type of things. I can add them. And these two terms are like, they're the same type of things that I can add them. Would anyone like to just unmute themselves and give me the final answer for this question?
X plus 11.
X plus 11.
Halala, x plus 11. Well done. Okay. All right. Okay. Now we're going to do this one. Okay. This is as hard as it gets in grade 8. Okay. All right. It does get harder in grade 9, and that's why you've got to make sure that you really understand your grade 8 maths well. All right. I'm going to draw in these little arrows just to help us. And I'm going to ask someone if they'd like to tell me what would my next line be. Okay, and so don't rush, just think about it. What would my next line be if I multiply these things into the brackets? And it's fine if you get it wrong. Someone unmute and have a go.
3x minus 3y.
Well done. I want you to carry on because you're doing so well.
Minus 2x minus
Well
2x plus plus 6y.
Hello, well done. Well done. Okay, excellent. Okay. All right, just mute yourself again, please. All right. So that is 100% correct. Okay. This minus 2 has multiplied with a positive x, giving us negative 2x. That negative 2 has multiplied with a negative 3y. Now, take it slowly. A negative times a negative is positive. Okay. A 2 times a 3 is 6. And then we've got a y. We are not finished. We're not finished because there are some
So we have like
terms.
terms.
Okay. Would you like to give me your final answer?
X plus 3y.
X plus 3y.
Well done. Well done to both of you. Okay. Okay. And I know there's some other people also answering. It's going to be 3x minus 2x is just 1x, and minus 3y plus 6y is plus 3y. Okay. Now, guys, in exactly the same way, remember when I talked about doubling 7? If I asked you guys to halve 18, okay? Halve.
So you made a mistake.
Sorry, thank you very much. I really appreciate you pointing that out to me. I did make a mistake. We said x plus 3y, and I wrote 3 plus 3y. Okay. All right. If I asked you to halve 18, what's the answer? It's
6.
9. No, 9. Okay. All right. If I asked you to halve this, and this is the same as 18, if I asked you to halve 10 plus 8, which one must I actually halve? Must I halve the 10 or the 8 or both?
Both.
Both. Okay. So it will become 5 and plus 4. Okay. So look at this.
9.
When we are dividing, guys, when we're dividing this stuff by 2, all right, we can write this like this. 4x divided by 2 plus 8 divided by 2. I want you to think about fractions. When you add, if I asked you to add these two fractions, have they got the same denominator? Yes. So do you agree we could go to there? Okay. Now, what we're saying is we can actually go from the top line to the bottom line. So when we're dividing, we must divide every piece. Okay, now who can tell me, what do you think the answer is when you have 4x and you divide it by 2, and you have 8 and you divide it by 2? Anyone want to give me an answer here?
2x plus 4.
Hello, well done. 2x plus 4. 2x plus 4 is 100% correct. Okay. All right. Guys, the next break, I'll tell you, and it is in fact going to be our last break. I'm just reminding myself, the next break is at 12:15. Okay. And it will be our last break, and then we'll go through to the end. Okay. Now, the next thing I want to take you on, guys, I want you to just mute yourselves again, please, guys. Just try muting yourselves again, please, everyone. All right. Thank you. It looks like you've managed to do that. I didn't have to do it, which is great. We're getting better. All right, guys, I want to talk to you about solving an equation. Okay. And I also, I'm just going to talk a little bit here before we do some questions. All right. Two big ideas. Okay. If I have an equation like this, okay, guys, just please mute yourselves. All right. Otherwise, I'm going to have to mute everyone permanently. All right. I'm trying to find remember we said X is a variable. It can have any value. Because we're now in an equation, there's only one value of X that's going to make this thing work. Okay. And I'm going to talk you through an idea here. Okay. I'm going to ask what is happening to X. Okay. X is being multiplied by, yeah, so we're going to undo, and it's as you say, it's called an inverse. X is being multiplied by 3. That's what 3x means. Then we're subtracting 4. Okay, now I'm going to just ask you just to think about something. This is like getting dressed and getting undressed. Okay, if I get dressed and I've got just 3 things of clothing, I've got underpants, longs, and shoes. Listen carefully. What goes on first? The underpants, then the longs, then the shoes. When I get undressed, which one comes off first?
The shoes.
The shoes, then the longs, and then the underpants. Okay, so listen to this. X is being multiplied by 3, then we are subtracting 4. When we undo this, we want to work backwards and we want to undo those things. So I'm going to write with a green pen. What must I do to undo this?
3x equal to 14
No,
plus 4.
I just want words. I don't want variables. What must we do? We must
Divide.
Okay, but must we divide first or must we add 4 first?
You must add 4 to both sides.
Well, okay, yeah. We're going to add 4. Then, guys, we're going to add 4. Then we are going to divide by 3. Okay, and the reason being it's for the exact same thing as the kind of getting dressed and the getting undressed. Okay, notice multiplying by 3, the way we undo multiplying by 3, we divide by 3. The way we undo subtracting 4 is adding 4, but the order is very important. Okay, and I've given you an example of getting dressed. I'm also going to give you an example. You might have played a party game called Pass the Parcel. You get some sweets or something, you wrap them up. You put more layers of paper. Maybe you use blue paper first, then green paper, then red paper. Blue first, then green, then red. When you unwrap that present, which paper comes off first?
Blue.
No, the blue one's inside. Then the green, then the red. Which one comes off first?
The red.
Green.
The red. Okay, so it's exactly the same thing here. We are, okay, please just mute yourselves, guys, okay, because I'm hearing cockerels crowing and all sorts going on. Okay, all right. Now, guys, the next thing I'm going to tell you about equations. An equation is like a set of scales, okay? And it is balanced. All right. So, for example, maybe here you've got 5, and maybe over here you've got 3 plus 2. It's balanced, okay? And what tells us that an equation is balanced is the equal sign. All of these equations have got equal signs. Now, if an equation is balanced, or scales are balanced, and I add 5 to both sides, will they stay balanced? If I add 5 to both sides, it's balanced, and I add 5, will it stay balanced?
Yes.
If I double what's on both sides, will it stay balanced? Yes. If I add 5 kilograms to one side and 4 kilograms to the other side, will it stay balanced?
Nah.
No.
No.
It won't be balanced. Okay. So we want to do the same thing to both sides. Okay. Now I'm gonna actually go up with this question. Okay, just because I haven't got space. How, and I know you've probably been taught something here, and I want you just to listen very carefully here. I want to get x on its own. I don't want this -4 on this side. How can I get rid of the -4? What could I do to both sides?
Plus 4.
Well done. I could +4 to both sides. Now, guys, if I +4 to both sides, that -4 is not there anymore. And the 14 becomes what if I +4?
Negative.
What?
18.
It becomes 18. Okay. All right. Now, what does 3x mean? It means 3 times x. How can I get rid of this 3? What must I do to both
Divide by
sides?
3.
I'm going to divide both sides by 3. 18 divided by 3, 6. 6 is the answer to this equation. It's the only answer to this equation. And we can go and check it. If we put 6 back in here, 3 times 6 is 18, -4 is 14. Right, let's do a couple of equations, because after the last break, we'll do some geometry. Okay. All right. So, guys, I'm trying to get x. Can someone suggest a good first step? And remember, I'm going to ask you which side, what are you going to do? What can you do to make this a little bit better?
You're gonna subtract x from both sides.
Okay, I wouldn't subtract x from both sides. I'm going to show you what you get if you subtract x from both sides. 2x take away an x is x, and 11 take away an x. That there is correct. We've taken an x off both sides. It's still balanced, but I don't think it's better than it was. I actually think it's worse than it was. So I'm going to run that out. Okay, I'm going to ask someone. Can someone suggest something? Just mute yourselves, guys. Yeah, I heard someone say -1 from which side?
Both sides.
Halala, from both sides. If I'm -1 from both sides, my next line will be 2x equals what?
10.
10. Well done. Okay. Now, that looks better to me. All right. And who can tell me now, what's the last thing I should do to both sides to get to 1x?
Divide by 2.
Divide both sides by 2, guys. And I get x equals 5. Do I need to write this 1 here? No, I don't need to write the 1.
No.
Is it wrong to write the 1? No, it's not wrong. It's not wrong to write the 1, but we don't normally write stuff we don't. We don't normally write stuff that we don't need to. I don't need to write. Okay. All right. Let's do this one. Oh, I don't like this -2 here. Who can tell me what should I do to both sides?
+2.
+2. Well done to both sides. What will it look like if I plus? What happens if I +2 to 19?
21.
Yeah. Now, guys, what is 3x mean? I don't want the answer. I just want someone to tell me, what does 3x mean?
3 times x.
Well done. So it means 3 times x. How can I undo timesing by 3?
Divide both sides.
Divide by 3 on which side? Which side?
Both sides.
On both sides, guys. On both sides. X equals 7. Well done. Okay. All right. Now, look at this, guys. Everything is connected. Sorry?
7.
7. Yeah, x equals 7. 21 divided by 3 is 7. Okay, guys, we're going to do this one next. Okay, this one over here. Now we've got x's on both sides of the equation. It doesn't matter as long as we do the same thing to both sides. Can someone tell me what should I do to both sides here to get a better thing?
-1 of the x's on both sides.
Okay, so that's a good idea. Okay, why don't we take these away?
Why don't you put the x's on both to one side?
That's what we're going to do.
Yes, so separate the like terms.
Correct. Guys, all of you are correct. Okay. Let's subtract 2x from both sides. And I want you all to think, I'm not going to write it down yet. I want you all to think, what will my next line be if I subtract 2x from both sides? Okay. And I want someone to tell me what it is.
4x minus 2x.
Careful.
4x plus 2x.
You see button.
Guys, if we subtract 2x's from here, what are we left with?
2.
2x. We've still got the plus 8. And if I subtract 2x's from here, what am I left with?
20.
20, yeah. Those 2x's I've subtracted. Guys, I've subtracted 2x's from both sides. My equation is still balanced. Okay. I want to ask you, is this better or worse than it was?
Better.
It's much better. It's much better. Can someone suggest a next line? And I want you to tell me what you're going to do, and I want you to tell me what your answer is going to be on the next line.
I have to minus 8.
Well done. You're going to minus 8. From which side?
On the right side.
From both sides. Okay. Tell me what your next line will be if you minus 8 from both sides.
Going to be 2x is equals to 2x is equals to 12.
Well done.
Sorry, so
Is this yeah? Christian,
so I went. I shifted 2x to 4x aside. I added them together to get 6x equals 20 minus 8. I went 6x equals 12.
Okay, and so you're wrong. Okay, and the reason you're wrong, all right, because I don't know how you got 6x. I do know how you got 6x. You actually added 4x and 2x. You can't. These 2x's are positive 2x's here. But if we subtract 2x from both sides, all right, then we don't get 6x. Okay, I'm gonna come back to what you just said. Let's finish solving this. Okay, what's the last thing I need to do to both sides to get the answer?
You divide by 2.
Divide by 2 on both sides. Now, guys, I'm going to show you. We're going to check this answer. If x is 6, 4 times 6 is 24 plus 8. We get 32 on the left-hand side. If x is 6, 2 times 6 is 12 plus 20. We get 32 on the right-hand side. That's the only answer to this question. I'm going to do this question again, okay, and I'm going to do it differently, okay. This time, I'm going to subtract 4x from both sides. And I want you to think about what will it look like if I subtract 4x from both sides. It will look like what? What will the left-hand side be? If I subtract 4x, the left-hand side will just be 8. What will the right-hand side be if I subtract 4x from 2x? Guys, 2x minus 4x.
Negative 2x.
Well done, negative 2x. Okay, now, I don't want this 20 here. What could I do to both sides to get rid of the 20?
Minus 20.
Minus 20 from both sides. If I minus 20 from 8, I get minus 12.
12.
And here, I'm minusing the 20, so it's gone. Now, what is happening to x here? It's being multiplied by negative 2. How do I get rid of this? What must I do to both sides now? I'm going to
Divide by 2.
Not by 2,
6.
by negative 2. All right. And guys, what is a negative number divided by a negative number?
Positive.
Positive. So, you see, I've done this question 2 different ways. Okay. But I've got the right answer both ways. Okay. But the one on the left is actually a little bit easier because I didn't have negative numbers to deal with. But don't be scared of negative numbers. We're good at those. Okay. Can anyone suggest what I should do here to make this one over here better?
Subtract x on both sides.
Well done. And tell me what your next line will be if we subtract x on both sides. So I want you to take away an x here, and I want you to tell me what you're going to get.
It's gonna be x
X is equals to 6.
X plus 3 equals 9.
Well done. Well done. X plus 3 equals 9. Guys, don't leave out steps. I heard someone say the answer, and you're right. The person who gave the answer there was right. I want to ask us, is this better or worse than it was? I want you to picture you playing. Yeah, I want you to picture you playing golf, and you hit a ball. You must now decide, must I actually take that shot again? Or can I walk to the ball and play my next shot? This is better. What could I do to both sides to get the final answer for x now?
-3.
Simplify.
-3 from both sides, and there's our answer. Okay, now I'm going to check. I'm going to check if you're right, because if you're telling me that x is 6, if x is 6, here on the left-hand side, I'm going to get 15. Okay, and if x is 6, here, sorry, this is the right-hand side, sorry. If x is 6, what's 2 times 6? 2 times 6 is 12. 12 plus 3 is?
15.
15. Hala, we've got it right. Okay, now, let's go back to this one, okay? We will take a break just now, okay? Like we've got another minute, okay, or two. This one, guys, we don't like these brackets, do we? But do we know how to get rid of the brackets? Who can tell me what will, yeah. Who can tell me what will it be if I take out the brackets here?
Distributive law.
Yes, yeah, so do it.
2x plus 6.
Sharing is caring.
2x plus 6 plus 1 equals 17. Okay, guys, just mute yourself again. Is this better or worse? I think it's better. Let's collect some like terms here. What does that simplify to? What does that left-hand side simplify to?
2x plus 7.
2x plus 7 equals 17. Can someone suggest something that I could do to both sides to get rid of the just tell me, what could we do to both sides to make it better?
17 minus 7, then you're going to divide by 2.
Yeah, but just write it down. Hey, do it one step at a time. We're going to minus 7 from both sides. And the last thing we're going to do is we're going to divide both sides by 2, and we get our final answer of 5. Can we check it? Of course, we can check it, guys. If I put 5 in here, I'm going to get 8 inside the brackets. 8 times 2 is 16. 16 plus 1 is 17. It works. It makes sense. It always makes sense. Okay. Now, this one over here. Yes, I'm a bit scared now. Okay. I'm a bit scared of this one. What is happening to x here?
It's in a fraction.
Yeah, it's in a fraction, but what would we say? X is being what by what?
It's being divided by 4.
Chat.
It's being divided by 4. How do we, guys, listen very carefully to this. How do we undo dividing by 4?
Multiply.
Timesing by 4.
100%. We're going to times by 4. But we need to times by 4 on both sides, and we need to times every term on both sides by 4. When we multiply this first one by 4, we just get, okay, I'm going to go over here. We're just going to get x, all right? Because x was being divided by 4. Now we're multiplying it by 4. We're just going to get x, okay? What happens when I multiply 1 by 4? What do I get?
4.
4. And what happens when I multiply 11 by 4? What do I get?
44.
44. Is this better or worse?
Better.
It's much better. What should we do to both sides now to get my final answer?
-4.
-4 from both sides. Final answer is 40. We can go and check it. If we put 40 in here, 40 divided by 4 is 10. 10 plus 1 is 11. 11 equals 11. Okay, right.
X
Okay, guys. Right. We are carrying on. It's 12:24 and we into our last session. Okay, so there's a lot of stuff here that really yeah, like with all of this maths, it really makes sense. So I'm just going to show you one or two things here. The first thing is here, I've got some lines that actually sticks. Just going to quickly show you. All right. So we've got these two green sticks and an orange stick. Okay. And we've got different types of angles, and this is something you just need to learn. All right. And that is that when the lines are parallel, so the green sticks are exactly the same distance apart, okay, everywhere. Then we've got angles that we need to know about. There's ones called corresponding angles. So here and up here, they're in the same corresponding positions, or here and here, okay. And they will be equal when the lines are parallel. We've also got what are called alternate angles. To alternate means to swap. So these angles are swapping on opposite sides. So you can see where my finger is there and my finger is there. They are on opposite sides. And then the last one we call co-interior. Co means together. Interior means inside. These two over here are together inside. So are these two on this side together inside. They aren't equal. If I just hold this up again, you can see the ones that are together inside, they aren't equal. They are actually what we call supplementary. They add up to 180 degrees. Okay. Now you might be thinking, oh, good, we finished with algebra, we're on geometry. But we're going to use some algebra, and I'm going to show you right away. Here, I'm going to look at this question here. All right. Let's see if we can work out what x must be. So we're going to create an equation, all right? And we're going to give a reason. All right. Who can tell me what's my equation going to be here? And remember, an equation has got an equal sign in.
180 degrees minus 27.
Okay. So some people are solving the equation already. I'm going to go x plus 27 degrees is 180 degrees. And we need a reason, okay? And the reason, angles on a straight line.
A straight line.
Okay, angles on a straight line add to 180 degrees. Okay, now we've got an equation. Can anyone suggest what should I do to both sides? I want you, every time you see an equation, I want you to think of a set of scales. What should we do to both sides to solve this equation? It's an easy one, huh?
Minus 27.
Simplify.
Minus 27 from both sides. Guys, 180 minus 27 is 153 degrees. Okay. All right. Now, so there we've got x. Okay. Right. Here's another one. What do we know about these angles that are across from each other?
Vertically opposite.
Well done. They equal. So we can
opposite angles, sir.
Well done. So there's our equation. 2x plus 9 degrees is 29 degrees. Now we've got an equation to solve. Can someone suggest something that we could do to both sides to get a bit closer to the answer?
Minus 9.
Well done. We can
Minus by
minus 9 from both sides. What will I have here if I minus 9 from here?
29 minus 9.
What's 29 minus 9? I think we can work that out.
20, bro.
It's 20. Okay.
20.
Now, guys, that's not my answer. What's happening to x? You can tell me in words. What is happening to x?
X is getting multiplied by 2.
Well done. It's getting multiplied by 2. How do we undo that?
Divide, sir.
On which side?
Divide by 2.
Which side?
Both sides.
On both sides.
Both sides. Both sides.
20.
There's our answer. Okay. All right.
Answer 10.
Okay. Now, I'm not going to do all of these. What do we know about all these angles? What do they all add up to?
360.
Yeah. So these ones would all add up to 360 degrees. So we write it all. In fact, let's do this one. We'll do this one. Okay. So 2x plus 101 plus 7x plus 79
Equals
Is that
to
everything?
360.
That's
Is equal
everything.
360.
That equals 360. I need a reason. All right. Angles
Revolution.
round
Point.
Points.
A point.
Yeah. Okay. Right. Now, let's collect some like terms.
2x and 7x.
Yeah. Okay. And these are also like, huh? Okay.
Yes,
So what have we
sir.
got? What will my next line be
The
if I add my
lactose are
like term?
2x and 7x.
Sorry, I'm going to add
So
that.
it's gonna be 9x is equal to 360 minus 101 degrees minus 79 degrees.
I hear you. I'm actually going to I'm going to add these like terms and keep them on this side for now. Okay. I actually get that. What could I do next to make it better? And the learner that just said that you're right. What are we going to do next? We're going to what should we do?
Minus 108 on both sides.
Well done. And if I minus 180 on both sides, over here, I'm just going to have 9x on top. What am I going to have over here if I go 360 minus 180?
180.
Well done. And what's the last thing I must do to both sides to find out what 1x is?
Divide by 9.
Divide by 9.
On both sides.
180 divided by 9, that's easy. 18 divided by 9 is 2, so 20 degrees. Okay. All right. And that's what 1x is. Do I need to write the 1 here? Do I need to write that 1?
No, sir.
No, I don't need to write it. Okay. It's not wrong to write it, but I don't need to write it.
Not compulsory.
Okay. Now, let's look at this one over here. What sort of angles are these?
Are you even paying attention?
Yes.
I guess just mute yourselves, please.
Alternating.
Well done. They are alternate angles. Okay. What do we know?
You mute.
Mute.
I'm going to mute everyone now.
To Mackenzie, chat.
Okay, I've muted you all. Okay. All right. So we've got alternate angles, guys. And so the way we're going to work out what we're going to do now, all right, is we're going to put the alternate angles equal. So we're going to write 7x minus 20 degrees equals 5x plus 20 degrees. Unfortunately, even if I solve this equation correctly, I'm going to lose a mark if I don't give the reason. And the reason, guys, is not just alternate angles, okay? All right, we can't just say alternate angles, and I'm going to explain why. These angles here, all right, this one here and this one here are alternate angles. Do they look equal? They're not equal. Why aren't they equal? Because the lines aren't parallel. They are only equal when the lines are parallel. So whenever we talk about alternate angles or corresponding angles or co-interior angles, we must say parallel lines. That is very, very important. If you don't,
So what do those arrows mean?
That's what the arrows mean. The arrows mean that the lines are parallel. But when we give our reason, we must say parallel lines. If you leave out that shaded yellow piece, you're going to lose a mark. All right. Now, guys, we've got an equation. All right. So, yeah, I know you thought, I can't wait to do geometry because we're not going to do equations. Here we are. We're doing equations, more equations. Can someone suggest something that I could do to both sides that would make this better? I don't want the answer. I just want a better next step.
Find like terms.
Yeah, so yeah, but can you tell me, correct, we want to get all the x's on one side, but how are we going to do that? Can someone tell me, what are we going to do?
Minus 5x.
7x plus 5.
Okay, just listen. I'm not sure who said it, but someone said minus 5x. Someone said 7x plus 5x. Guys, you're not going to get 7x plus 5x. Someone said, let's minus 5x from both sides. And I want you all to think about what will it look like if we minus 5x from both sides? What will this become?
It will be x minus 20.
It will be 2x minus 20 degrees. Now, let's minus 5x from this side also. What do we get if we minus 5x?
X plus
20.
Not x plus 20. We just get 20. Okay, and I'm going to ask us again.
20.
Is this better or worse? It's better.
Sorry.
Much better. Okay. Who can tell me a
So-
next? Yes.
So is it wrong to say 7x plus 5x and then put
It
them
is.
on one side?
No, it is totally wrong. It's totally wrong to say 7x plus 5x. I'm glad you're checking that with me. You can't just say, well, because it's not 7x plus 5x. We haven't got 7x and 5x
Minus
on the same
5x.
side. Okay. It's actually
Minus 5x.
it's minus 5x. Yeah. It's actually 7x minus 5x minus 20. That's all on the left-hand side equals 20. Okay. Now, what I did is we've just, that's what we've done, but we've simplified it to 2x. Okay. Who can tell me what's a good next step now?
Plus 20 on both sides.
Plus 20 on both sides. Okay. All right. And if we add 20 to both sides, what do we get?
4x is equal, 2x is equal to 40 each.
2x is equal to 40 degrees. 100%. Now, what's the last thing I should do to both
Divided
sides?
by 2.
Divide by 2.
Divide by 2 on
And we
both
get 20
sides.
Oh,
we get
yes.
on both sides. And we get 20 degrees. Guys, I want to show you that if x is 20 degrees, 5 times 20 is 100. 100 plus 20 is 120. That angle will be 120. If we've got it right, this one will also be 120. 7 times 20 is 140. 140 minus 20 is 120. This is right. It's definitely right. Okay.
So,
Yes.
how much marks should we get for one of these?
How much? What?
Marks.
5. I'd say this question here would be 4 marks or 5 marks, and I'll show you where they're coming in from. 1 mark for an equation. Okay. 1 mark for the reason. All right. Then probably so in maths we have what we call method marks and we call accuracy marks. So there might be a method mark for the equation. In other words, that you've tried to create an equation. It might be wrong, but you've tried. You know you need an equation. And then there would probably be an accuracy mark. So in other words, you not only have you got an equation, but you've got the equation right. And then there will probably be 2 marks for the solution. Okay, so we will look for a mark for you here if you've done something correct, and we'll look for a mark for you here if you've done something correct. The nice thing about maths, though, guys, if you make a mistake, let's say you make a mistake here and you wrote 6x plus 20 or whatever. If you do everything else right from then on, you only lose 1 mark. Okay, so we don't only look at your answer, we look at your working and your method. Okay, and that's why I try not to leave out steps, because when you leave out steps, if you leave out a step and you make a mistake, we can't give you any marks for it. Okay. All right. Okay, guys, there's some stuff here that you need to learn. Okay. All right. And that's just about the properties of shapes. Okay. All right. And then the last little piece there's some graph stuff. Okay. And we'll just quickly look at a graph thing here. Okay. So here we're going to plot some points here. Okay. And we know, yes.
So is there an answer sheet for this, sir?
I don't know. It's a good question as to whether there's an answer sheet for this. If there's not an answer sheet, I will create an answer sheet. Okay, and
Thank you, sir.
I'll put it up. I'll put the answer sheet up on the same place where on the SIMI website. Okay.
Thank you, sir.
Okay. All right, guys, just have a look at this. 5 burgers cost 45 Rand. So what does 1 burger cost? How can we work that out? And remember, with all these
45 divided by 5 is 9.
45 divided by 5, 9 Rand. Okay. So R9. So
It was four.
how many burgers did I buy if it's 18
One.
rand?
Two.
2.
That's fine.
8 times 9 will be
When it's just playing out
72.
at
10 times 9 will be
Bro, can you please mute?
90.
Please, I need-
180 divided by 9 will be 20. Okay, guys, if we go and plot these points, okay, all right. Basically, it's going to be quite hard for me to draw this here without a ruler, but okay, obviously 0 burgers will cost 0 rand, but I know that 20 burgers cost 180 rand. Okay, and I also know, so basically, I'm just going to join this to there. Okay, and we can go and check now with some of our other examples. So, for example, we said 5 burgers. 5 burgers cost 45 rand. Have a look at this. 5 burgers, we would go up here, and then we would go across here. Okay, and it says use your graph to work out the price of 6 burgers. So now 6 burgers, we would go, right, there's 6 burgers. Let's go up here. We actually know the answer. 6 times 9 is 54. But if we check across here and we go across, we get 54.
Sir,
Yes.
can you please go to the table?
Yes.
Your line is not straight. Thank you.
Sure. My line's as straight as I could draw it. Okay. Oh, you talking about these lines here? Yeah. The dotted lines.
Oh, it's Handwayo, bro. Please mute.
Okay. And then, guys, how many burgers can one buy for 72 rand? So now we're going to work the other way. We're going to go off the rands. Okay. We're going to find 72 and we're going to go across here. I know it's not straight. Okay. I haven't got a ruler here. All right. And we're going to go down. And actually we get, yes.
I have a question. Why do they have to be dotted lines?
Okay, it's a good question. They don't have to be dotted lines. Okay. All right. They don't have to be dotted lines. And I could probably draw them a bit straighter if they were dotted lines. Okay. This comes to 8. Okay.
Is this
All
how
right.
we set it out in the exam?
So I didn't hear that.
Is this how we're going to set it out in an exam?
Yes. Yeah. Okay. This one, the graph's drawn for us. Okay. This is Boosie and she's running. Okay. She runs for 5 hours. After 5 hours, she's done 18 kilometers. Okay. So the first thing is, what was the total distance she covered? 18 kilometers. Okay. What was her average speed? Guys, remember speed is distance divided
Distance
by
over time.
time. Yeah. Okay. And we know, guys, we know that. We know it's distance over time because when we talk about a speed, we talk about kilometers per hour. Okay, so we must take the number of kilometers that she did divided by the number of hours. So it's going to be 18 over 5. All right, 18 over 5 is actually 3 3/5. It's actually 3,6. Okay, you can do that on a calculator. 3,6 kilometers per hour. All right. Okay, now it says, when did she stop? So what we need to look at is at what stage was the time moving, but the distance wasn't moving? Which hour?
To the first and the second hour.
Well done. Hello.
Yes.
Guys, over here, all right. Okay, over here, time is going by and distance is not changing. So she stopped for 1 hour she stopped for the second hour, basically, if we want to write it as quickly as possible. She stopped for the second hour. Okay. All right. Now, when was she going the fastest? Now, guys, for her to go the fastest, we actually want the line to be going uphill as steeply as possible. Okay.
The second and third hour.
Actually, it's actually in the third hour. Yeah, it's actually because this is the first hour, this is the second hour, this is the third hour. Over here, the line is going up the steepest. And we can, when was she going fastest? Okay, in the third hour. And let's work out how fast she was actually going. Okay, because at the beginning of the third hour, she had done 4 kilometers only. And at the end of the third hour, she had done 12 kilometers. So how many kilometers did she do in that hour?
8.
8. Okay. So in the third hour, she was actually going at 8 kilometers per hour. Okay. And that's when she was going fastest. If you're not sure, you can go check. Like in this hour over here, she only went 2 kilometers from 12 to 14. So here, her speed for this one would be 2 kilometers per hour. All right. Okay. So this is just about interpreting graphs. Okay. The next thing is Pythagoras. Okay. And remember, we're going to make equations. Okay. And the thing with Pythagoras, the two sides that make the right angle, you must square them and add them together, and that gives you the other one squared. So I'm going to do just 2 examples here. In this one, it's going to be 8 squared plus 10 squared equals x
18.
squared. Okay, guys, we can't add the 8 and the 10. We got to square them first. This is 64. This is 100. X squared is 164. And then I'm going to square root both sides, okay? And this is a place where I will use a calculator because I can't do that in my head, okay? Try not to use a calculator, guys, where you can use your brain. Your brain is like a muscle. If you go to the gym and you pump iron, what happens to your arm? It gets stronger, okay? All right, your brain is exactly the same. If you use your brain, it gets better. If you use a calculator to multiply 3 by 7, your brain is going to go mushy. Okay, our answer here is 12,8. Okay, and we must remember to put the units 12,8 centimeters. Okay, now look at this next one. All right, the next one, who can just mute everyone there. It sounds like someone was kind of having a shower or something. All right, okay, who can unmute themselves and give me the equation? I don't want the answer. I want what squared plus what squared is what squared for this one. Okay,
6 squared
Herman.
plus 11
11
squared.
squared.
Okay,
squared
11 squared.
plus 6 square.
no,
is
guys,
equal
it's
to
not going to
x
be 11
squared.
squared plus 6 squared. The two,
Oh, 11
look here.
squared times.
Oh, the
No,
two
not
sides
times.
that make the right
I mean
angle.
minus.
So it's
Guys,
going to be
11 squared minus 6 squared.
okay, yeah, I don't want you to do, you are right.
X plus
This
6
is-
equals 11.
Minus
Yeah,
the
guys,
side.
guys, what I want us to do, all right, I want us just to always create the equation with adding the two that make, so in other words, x squared plus 6 squared is equal to 11 squared. Okay, now
sides
this
that
is
make the right angle.
yeah, the two, 100%. The two that make the right angle, you square those and add them together and you get the other one squared. Okay, so now this is an equation, okay? Let's just work out 6 squared we know is 36. 11 squared is 121. What, guys, just quick, I'm going to mute you. Just quickly tell me what must I do to both sides to get the x's on their own?
Minus 36.
121 minus
Well done. I must minus 36. Okay. So I've got 121 and I'm going to minus 36. I get 85. So x squared is 85. Okay. I've minus 36 from both sides. What must I do? How do I undo squaring, guys?
85 divided by 2.
Not divided by 2.
You square
It's a
root
square
them.
root.
Square root. I need to find the square root. It's not divided by 2. The square root of 85. Okay, and that is 9,2.
9.2.
And this one is also centimeters. Okay, then guys, the last thing we're going to look at is just okay, so here's a like a word problem. Okay, we've got to draw a little picture for ourselves here. We've got a ladder that's 3 meters tall. Okay, so that's 3 meters. That's our ladder.
Sir, please go back. I'm not done.
Sure. Okay.
Thanks.
Okay. And guys, it's leaning against the wall to a height of 2.4 meters. These questions are always going to have a right angle in them. So there's the right angle. This height over here is 2.4 meters. And the question is, how far is the base of the ladder from the wall? In other words, how long is this green line? Okay, and I'm going to put a variable here, and I want someone to give me the equation. What squared plus what squared will be what squared?
X plus 4 squared plus x squared equals 3 squared.
Yeah, absolutely. X squared plus 2.4 squared. It doesn't matter if you've got those. It doesn't matter if you've said 2.4 squared plus x squared. That must equal 3 squared. That's how Pythagoras works. I'm going to remind you again, it's about the sides that make the right angle. You square those two and you add them together. Now, okay, 2.4 squared, guys, is 6.25. Okay, I happen to know that. All right. I hope it's 6.25. I don't think it's 6.25 at all. It's not. It's 6.76.
I'll check.
I think it's 6.76. I'll check now. And 3 squared, I know for sure, is 9. What should I do to both sides to get rid of that 6.76? What should I do to both sides? Minus what? It's not 6.76. Paul. It's not 6.76. Okay, I'm trying to show off with my numbers and I'm making mistakes. Okay, it's 5.76. Okay, but so what must I do? I must minus 5.76 from both sides. So I'm going to go 9 minus the answer that I just got, and I get 3.24. So x squared equals 3.24. What must I do to both sides now?
Square root.
I must square root both sides. Okay. And so when I square root 3.24, I get 1.8. Okay. So x equals 1.8 meters. All right. And guys, then the last topic for the year is around perimeter and area. And you need to know a few things. You need to know that for a circle, okay, that's a dreadful circle. That's a dreadful circle. I'm going to try and draw a better circle. Okay, guys, for a circle, we've got two sort of straight lines in the circle that are interesting. One is called the radius, and then the other one is called a diameter. Okay. All right. And a diameter, guys, is twice as long as a radius because there's a little r here to a little r here. So the first thing about a circle is that a diameter is to get a diameter, you double your radius. Guys, if I solve this equation, watch what I'm going to do. I'm going to divide both sides by 2. Radius is actually diameter divided by 2. Okay, so you need to know that relationship. You need to know that the circumference, now the circumference is the same as the perimeter. It's the whole way around. All right, and the formula for circumference is pi. No, it's not anything squared. It's pi times the diameter.
Radius.
Okay, it's pi times the diameter. But I'm just going to have to mute people again.
Isn't it 2 times pi times radius?
Yeah, it is. It is that as well, guys. Because watch what I'm going to do now. I'm going to write this down again, but instead of writing diameter, I'm going to write what diameter is equal to. Diameter is actually equal to 2r. So we don't normally write it as pi 2r. We normally write it as 2 pi r. Both of these are formulas for circumference. You need to know both of them. Okay, you need to know that circumference is pi times diameter or 2 pi times radius. You also need to know that the area of a circle is pi times by the radius.
Radius squared.
Okay, all right. So, and then, guys, lastly, you need to know that the area of a triangle
Half base times height.
Is half the base times the height. Yeah. Base times height. Okay. And so you might say, okay, so this says determine the area and the perimeter of this shape. The area is going to be easy, isn't it? Because I know it's going to be half the base times the height. Okay. And you can multiply these numbers in any order. So maybe I'm going to go half of 12 is 6 times 8 is 48. 48 what? It's an area, guys. 48 what units? Not centimeters.
Centimeter squared.
Well done. Centimeters squared. Okay, now I'm not going to, now guys, perimeter means the whole way around. Okay. That's in Kenya. We have a problem, okay? Because I don't know this. Can I work this out though?
I have a question.
Yes.
How can I work it out?
So,
what theorem?
So
Yes.
how do you know which one's the base? And let's say they turn the shape around. How do you know which one's the base?
Okay. It's a great question. It's a very, very good question. It makes no difference as long as the base and the height are perpendicular to one another. So if we redrew this triangle so that it looked like this. Okay, sorry. If I redrew the triangle so that it looks like this. Okay.
So Pythagoras.
Yeah. So I'm doing a different question now, but if I wrote it like this and I use 8 as the base and 12 as the height, I will get exactly the same answer because it doesn't matter what order we multiply numbers in. What is important is that there must be a right angle. We need to know that the base and the height are perpendicular to each other. Okay. Someone said Pythagoras.
So,
you absolutely yes. So yeah.
So for perimeter for a triangle, do you say length times breadth times height, or are you doing Pythagoras?
No. What are you talking about? The area of the triangle, I'm doing half base times height. There's the formula. I wrote it down here. Half.
No, I mean perimeter.
For perimeter.
Isn't it side plus side plus side?
For perimeter, you're just adding up all the sides. Yeah.
That's what
So my problem is I don't know this side yet, and someone's already said we can use Pythagoras. And remember, we will take the sides that make the right angle. We will square those two and add them together, and that will give us x squared. Okay, I'm not going to finish this question, guys, because it's quite straightforward, and I will put up the solutions. All right, this question's interesting, okay, because they ask us for the perimeter of this rectangle. Now, one of the things you need to learn and you need to know is that the opposite sides of a rectangle are equal. Okay, so this is 5x minus 2y. Who can tell me what will the perimeter be? And remember, the perimeter, we're going to go the whole way around. We're going to add up all the sides. It's going to be
2x squared.
Careful. It's going to be the perimeter.
Sides and perimeter.
I'm just adding up all the sides, guys. You see what I've done? I've started here. I've gone there. Then I've gone there. Then I've gone there. Then I've gone there. Okay.
So,
can we simplify that?
yes.
Yes. Let's look for some like terms.
Like terms, chat.
Five x plus 2x. So yes, we focus on the like terms.
Yep. So how many x's are there altogether there, guys?
10.
Oh.
I'm saying more than 10. I'm saying 14. 5.
Yes, 14.
7.
14.
12. 14x. And what about the y's?
And 4y. 4y's.
4y.
Plus or minus 4y?
Plus.
Minus 4y, guys.
Plus.
That's minus. Minus 2y minus another 2y. Okay, the person who thinks it's plus, I know why you think it's plus. Okay, you're thinking minus, when we minus a negative, it's the same as adding. That's correct, but we're not doing that here. We've got a value here and another value here. We're just adding them together. It's like -4 minus another 4. What's the answer to -4? I want you to think on a number line, minus another 4. It's just minus
-8 each.
Okay. All right. Then, guys, what about the area of this shape? How do we find the area of a rectangle? We're going to take the one side multiplied by the other side.
A equals L times B.
Now, guys, it's not 2x, it's 2y. All right, guys, do we know how to get rid of this bracket here?
Yes, sir.
Now, so
Yes, sir.
what are we going to do? We're going to go that time. Okay. So, guys, what happens when we multiply? And there's a whole lot coming together here because we're now multiplying 2x by 5x. I want you just to think, what's 2 times 5?
10.
10. And what's
15.
10x squared.
what, guys, what is, listen carefully, what is x times x?
X squared.
Well done, it's x squared, guys. And now I must multiply the 2x by the negative 2y. There's 3 different things I've got to think about here. I've got to think about, will it be positive? Will it be positive or negative if I multiply a positive by a negative?
It's going to be a negative.
Yes, and then 2 times 2? 2 times 2? 4. And then x times y, xy. Right.
Yep.
Okay, and guys, I cannot simplify this because these terms are not like that. They're unlike terms. Okay. All right. Okay, guys. Yeah. So we're gonna have to stop there. Some of these shapes, are like they're compound shapes. Okay. So this shape here, this is half a circle. Okay. So if we can work out the area of the circle, then we're going to divide by 2. This shape over here is a rectangle. That's easy. But we've got a problem here because we don't know how high this rectangle is. Okay, I'm going to draw in a 90 degree. Exactly. We've got to use Pythagoras. What I want to say with a question like this, you must try and show all your working. So you could write down area equals, and even draw a little picture. The area is going to be a semicircle plus a rectangle plus a triangle. And then the teacher who's marking it can see what you're doing. Okay. All right. Guys, I'm going to stop sharing my screen. All right. Just so that I'm kind of back on screen here. We're going to stop there. I really hope it's been useful. Okay. I want to encourage you to keep working hard. Yeah, this stuff that we're doing this year is very much the foundations for your maths later on. Okay. So guys, thank you very much. God bless all of you. Mag die Here julle almal seën. Nkulunkulu anibusise nonke. Yes, you can ask questions.
Thank you, sir.
Thank you.
Thank you, sir.
Sure. Enjoy the weekend, guys.
Thank
Keep
you,
working
sir.
hard.
Session, sir.
Okay, sure.
So can I ask you?
Yes, I'm waiting to hear it. Yes.
When is the
Thank
next
you,
session,
sir.
sir?
Thank you, sir.
Sure. The person who wanted to ask me a question, just stay online.
An example.
Ah,
Let's say you like do one step like chickens but the other
Okay, guys, I am muting everyone. All right. Lots of people are leaving. Okay. There's still quite a lot of people on though, but I'm just muting everyone just because there's someone who wants to ask a question and I just want to make sure I can hear it. So just unmute yourself and ask the question. There was a girl I'm wanting to ask a question. I can't see. Yeah.
Hi, sir.
Yes. Sir.
Yes.
So, sir, I was saying, so if like in an exam, so you
Yes.
you let's say you do you're supposed to do 4 steps, and then you miss one step and you do it wrong, but the others you do them right. So will like they give you marks for the one that you did wrong, or will you get the entire thing wrong?
So it's quite hard to answer generally, because obviously there's lots of different ways that could work, okay, in terms of exactly what you've done. The problem when if you leave steps out, it's much harder for a teacher to try and work out what you did. I'm going to try and I'm just going to share my screen again. I'm going to try and just give you like an example or two just to try and explain. Okay, so so for example, if you had something like, and I'm going to stick with equations. Okay, so if you had something like this, 3x plus 2 equals 23. Okay, and you you said to yourself, okay, if I subtract 2 from both sides, I get 18. All right, and then you said, and it's not right, okay, and you said now I'm going to divide 18 by 3 and I get 6. 0. Okay, 0 out of 2. All right, because the teacher can't work out what you've done. Okay, suppose you did this and you wrote
So don't
down,
you get a mark for the final answer?
No, but the final answer is wrong. Okay.
Oh.
Okay, the final answer is wrong. Okay, so suppose you did this. So here's the question again, and now you said, okay, 3x equals 18. Okay, that's wrong, but the teacher will keep marking it. Okay, now you said, okay, I want, if 3x is 18, x is 6. One out of 2. Okay, all right. Obviously, I'll just do it one more. I'll do it one more time to do it correctly, just so that I don't leave you with horrible maths. 3x plus 2 equals 23. 3x equals 7. Sorry, 3x equals 21. X equals 7. Okay, 2 out of 2. Okay, I'm going to do it one more time with the blue pen. 3x plus 2 equals 23. X equals 7. Okay, now this is interesting because I would give you 2 marks, okay, because you've done it in your head and you've got it right. But there is always a concern for teachers. Did you maybe, and I hope you wouldn't do this, but did you maybe look over and see another person's answer? You know what I mean? So the safest thing is to show you're working. All right. It's like driving a car with a seatbelt. Like, it's just the sensible thing to do. Show you're working wherever you can, because then when you've made a silly mistake, you can often get 5 out of 6 or 4 out of 5 for a question, and you've only made one mistake. So you've got the wrong answer, but we check everything. Okay.
So even if the sum is wrong, but you have the working out, you can
if you've done some correct maths, then you need to be credited for that. Yeah.
Oh, also I have one more question.
Yes.
When it's area for those 3 different shapes, you do the area for the shapes and then you add them together.
Correct. Totally. And that,
so the semicircle.
Yes. So I mean, I can quickly do that one if you want.
Yes, please.
I'll just share my screen again.
Yes, please. One more. That's one more. So sorry.
Okay, cool. Let me just find that question. Okay, so the first thing here in this question, we've actually got a problem because we don't know what this is. Okay, so I'm going to do it quite quickly because I know you guys are sharp. All right, remember the 2 sides that make the triangle, that make the right angle, we're going to square those 2 and get this. Okay, this comes to 25. This comes to 169. Now I'm going to subtract 25 from both sides, and I'm going to square root both sides. Okay, and these numbers I know they work out nicely. So this is 12, this whole line. Okay, now I want the area of this orange piece. Okay. And the formula for area of a circle is pi times the radius squared. But what is the radius of this circle? If there was a whole circle here, what's the radius? The diameter is 12.
Times 6 is the radius.
Well done.
Six.
Well done. So the
Yeah.
diameter is 6, but sorry, rubbish. The diameter is 12, but so the radius is 6. Okay, r equals 6. So this is going to be pi times by 6 squared over 2. The reason I'm dividing by 2, it's not a full circle, it's half a circle. The rectangle is going to be easy because it's just going to be the length times the height, 20 times 12. And the triangle is actually going to be easy as well. It's going to be half the base. What's the base? The base is?
The triangle.
Five.
The triangle
The
is
Yeah, the
5.
base is 5 and the height is
12.
12.
12.
And guys, there's my answer. Okay, obviously I put it into a calculator. I like doing mental maths. So 6 squared is 36. 36 halved is 18. So I'm going to take 18 and multiply it by pi. 2 times 12 is 24. There's another 0, so it's 240. Half times 5 times 12. I can multiply these in any order. So I'm going to multiply the half by the 12. What's half of 12?
6.
6. 6 times 5 is 30. So 6 times 5 is 30. So there's the answer to that. 240 plus 30 is 270. 18 pi plus 270. Okay, there's my answer. But obviously what I would do, I'd go to a calculator to get the exact answer. Okay, so I'm going to go 18 pi plus 270. All right, and I get 326,5 centimeters squared. Okay, okay. I'm also wanting, and guys, don't forget centimeters squared and not centimeters, actually meters, this question. But then they also ask for the perimeter, okay? And remember the perimeter, we don't count the lines inside. So when we do the perimeter, it's going to be 5. Watch where I'm going here. It's going to be 5 plus 20 plus this curved piece. Okay, we'll come back to that. Plus another 20 plus a 13. I'm not going to add these lines inside here. Are just showing me what shapes. Those do not form part of the perimeter. The perimeter is what if you were going to put a fence around the outside. That's what the perimeter is. The only piece that is a little bit interesting to work out is this piece. And remember, the formula for the circumference of a circle is pi times the diameter or 2 pi times the radius. You can choose.
2 pi.
Okay, so you can either go pi times 12. Okay. Or you can go 2 times pi times 6 because the radius is 6. This is also 12 pi. But that's for the whole circle. So what must we do?
Half.
We must halve it. Yeah, so we must halve it. So this piece of line here, just this piece here, is actually, this piece here is actually 6 pi. Okay.
Yes.
Yep. All right, guys, I need to go now. I will try and get a memo, a set of solutions for the whole document up for you guys. Okay.
Oh, bye, sir.
All right. Thanks, guys. Have a good weekend. Well done.
When is the next session?
Well done for your participation. I'm very proud of all of you. Okay. Cheers, guys. Bye.
Cheers.